Meme coins are one of the hottest sectors in the crypto industry, with multiple coins launching every single day that put in 100x returns or more, all thanks to popular Memecoin launchpads like Pump.fun. And in this video today, I'm going to show you how to code your own Memecoin launchpad just like Pump.fun, where anybody can create their own meme coin and launch it out into the wild. This is an amazing project to learn the fundamentals of blockchain development, how meme coins work, and also a great project to use for your portfolio if you're trying to become a highly paid blockchain developer. But don't worry, you don't have to be an expert to get started today, because I'm going to show you all the skills, programming languages, and technologies that you need while we're building the projects. I'll show you how to create the smart contracts, how to write tests, how to create the website, and how to put this on a blockchain. So I'm super excited to show you this today as a blockchain developer myself who works with this technology on a daily basis. So if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. And I put a ton of time into creating this video completely for free on YouTube. And the only thing that I ask in return is that you smash that like button down below. Go ahead and click it because it really helps this channel out on YouTube. And make sure you subscribe to this channel and also share this video with a friend. And finally, if you like what you see in this video today and you want to take the next step and increase your income, I can show you how to do that by becoming a blockchain developer step-by-step from start to finish over at dappuniversity.com/bootcamp. All right, so let's get into this. But before I do, I always have to issue these disclaimers. This video is designed to be for educational purposes only. I'm trying to show you the fundamentals of blockchain development. Obviously, there's going to be legal and regulatory concerns if you were to launch your own Memecoin launchpad live on the blockchain for real. But with that being said, let's jump in and get started. All right, so let's go ahead and take a look at the application that we're going to create in this video today. So we are going to create a blockchain-based Memecoin launchpad heavily inspired by the viral Memecoin launchpad on Solana called Pump.fun. Now, we've created our clone of that called fun.pump. This is going to run on top of the Ethereum blockchain or any other EVM-compatible blockchain like Base or something like that. So basically what this is a Memecoin launchpad where anybody can connect their wallet. They can create a new token. They'll list the meme coin. And whenever they list the coin, the creator of the platform is going to get part of the listing fee. And you can see that a new coin is created here with a picture, and then anyone can invest in this token and they can buy these coins. And whenever the funding goal is met, then the coin will successfully launch, just like Pump.fun. All right, so let's get an overview of how this project is going to work. So whenever a coin is listed, an investor is going to show up to this website with a blockchain wallet like MetaMask. They're going to fund it with some Ethereum cryptocurrency or Ether, and they're going to visit this website right here in their browser. So you can see that just like this. They're going to click on a coin. All right, they're going to enter in the amount they want to contribute. They're going to click buy. And whenever they do that, that's going to talk directly to this Memecoin launchpad on the blockchain. And that is going to issue tokens to the investor. It's going to send them back to their wallet. The developer who created the application is going to get a fee for creating the token. And then, of course, anyone can list tokens. We'll get to that part in a minute. So for each of these things, we're going to create the smart contract for the token launchpad. All right. We're going to do that with the Solidity programming language. That's the main programming language for writing smart contracts for Ethereum and many other EVM-compatible blockchains. We're going to create that contract with the hardhat smart contract development framework. This is one of the best frameworks for writing smart contracts on your computer. And for the other contract, the token, we are going to use Solidity for that as well, because every time you create a token, it's going to be a new contract. And for that, we're going to use ERC20 tokens. So this is the standard for how Ethereum tokens should work. We'll go into detail about how this works momentarily. And then finally, for the website, we're going to create the website that you see right here in JavaScript. All right. But specifically, we're going to use a framework called React.js and Next.js to code this out as well. And finally, let's look at a diagram of how the project is going to work in terms of the listing flow and the investor contributions. We'll revisit this diagram as we build the project, but I want to go ahead and introduce it to you now. So it first and foremost starts with the developer, the person who creates the Memecoin launchpad. Basically, they're going to put a smart contract on the blockchain for the launchpad. And what that contract is going to do is allow any other person with a blockchain wallet to show up to that contract and create a token. So you can see you've got the developer here, you've got the creator here, And so the the creator can talk to the Launchpad contract and tell it to create new coins. So the Launchpad contract is going to be able to issue an infinite number of coins, all right? And so every single time it does that, the developer is going to get part of the listing fee for this. So whenever somebody creates a coin, the developer is going to get paid, and then the creator is going to list a new coin, all right? And whenever they do this, the Launchpad is actually going to create new smart contracts for each individual coin. That's why it's called a Launchpad factory. We'll get into that in the coding, all right? But finally, from an investor standpoint, they are going to be able to, through the website, talk to the Launchpad contract. They'll invest in new coins here, all right, by sending Ethereum cryptocurrency or Ether to the Launchpad, all right? And whenever they do that, they'll, of course, receive coins if the project is successfully funded, all right? And when the project is successfully funded, the token will be live for trading. All right, so let's go ahead and start coding out the project. So in order to do this, you need a few basic dependencies on your computer. In terms of actual programs that you need on your computer, you of course need a terminal first and foremost. So if you're on Mac, you should have a terminal out of the box. If you're on Windows, you should have this. You could also consider Windows subsystem for Linux if you want to install that as well. But you need a terminal, and you also need a text editor. So I'm going to use VS Code in this tutorial. You can use whatever text editor that you like. But the only real system dependency that you need installed is going to be Node.js. All right. So what is Node.js? Well, it is a JavaScript runtime environment for your computer so that you can run JavaScript on your computer outside your web browser. It's going to let us, create smart contracts with the hardhat development framework. But most importantly, Node.js comes bundled with Node Package Manager, and Node Package Manager is what's going to let us install all the other dependencies on our computer, like hardhat, like solidity, like React.js, like ethers.js that we're going to use for this tutorial, okay? So you can see if you have Node installed on your computer already by going to your terminal and typing node-v, all right? I'm on version 20.10.0. You can use, at least that version. I highly recommend, if you want to, basically using the exact version that I am to avoid any conflicts, all right? So you can install Node directly from the Node.js website, just like this. You can just do point and click install, or you can install it from your terminal with a package manager, all right? And if you want to change the Node version, you can also use something like in, which will allow you to quickly change between Node versions if you want to as well. So once you have those things set up, you have a terminal, you have a text editor, and you have Node.js installed, you are ready to start setting up the code on your computer. So I'm going to put a link to this down in the video description below. So this is the final code solution for the entire project. So if you ever get stuck, you can download this and reference it. This is the main branch. But what we're going to do is we're actually going to take a Git branch called starter code, all right? And that's going to give us a template to get started quickly with, so we don't have to create every single thing from scratch, okay? So I'll put a link for this down in the description below. You can copy this link, and what you're going to do is you're going to go to your terminal. You're going to do git clone, all right? Which basically is just going to download this code. That's the command for it. But what you're going to do is give it a specific branch, all right? Because you don't want to just clone the main thing. So git clone -b, that stands for branch, and we're going to say starter _ code, all right? And then we're going to paste in the URL for the repository right here. Hit enter, and there you go. So you can see we download all the code. We can enter into that newly created directory with the cd command. We say cd fun-pump. And you can see that we're in the newly created directory, and I have my terminal configured to show me which Git branch I'm on, and you can see that you're on the starter code branch. Just as a sanity check, if you don't have this, you can just do git branch, and it will show you, in fact, that you are on the starter code. To get out of that queue, and then there you go. And so once you've downloaded that, you can go ahead and open up that project in your text editor. Again, I'm using VS Code. You can use whatever text editor that you like. But basically, you can see that we have some files already created for us. That's so that we don't have to create a new hardhat project from scratch, and so that we don't have to create a new React app inside of here. This is just going to save us a lot of time to get started. And if you browse through here, you can see that we have, some placeholder files like for the factory, for the token. There's no real substantial code in here. We'll create all this stuff from scratch, okay? You can see that we already have a place for our tests. And we also have the package.json file. Okay, so this is going to have all the dependencies that we need to install, which we'll do here in just a second. All right. So what are these dependencies? Well, first and foremost, this is hardhat. All right, this is the smart contract development framework that we're going to use. So hardhat is just a set of tools that you run on your computer that lets you create Ethereum smart contracts in Solidity. So it lets you download Solidity to your computer. You can compile smart contracts. You can write tests against them. You can deploy them to a blockchain. Hardhat also has the Hardhat development node, which is just a local blockchain that you can use for software development. It's got a lot of really nice stuff out of the box with hardhat. Okay. So what else is inside of here? Well, we've got ethers.js, which is going to come inside of hardhat. All right, that's going to let us turn our website into a blockchain website. We'll revisit ethers heavily throughout this entire tutorial. Okay. It's also got things like OpenZeppelin, which we're going to use to create the token, and also React.js and Next.js so that we can create the website as well. So let's go ahead and install these dependencies. We just listed them in the package.json file. But I'm going to go ahead and open up my terminal inside of VS Code. I'll use this terminal throughout the rest of the tutorial instead of my external terminal, just to keep things nice and clean. So just make sure that whenever you open your terminal, that you are in the correct repository here, fun.pump. You don't want it to be in some other folder, because if you run this command, it's not going to work. And then also, you can make sure that you're on the starter code branch. It'll show you that. Just do git branch, hit enter, hit Q to get out of that. And now I'm going to install my dependencies like this. I'm going to do npm install. All right, boom, there you go. It worked. We've got everything installed in our computer and we're ready to get started. Oh, and actually one more thing before we continue. There is one more thing that you need to make sure you have installed, which is MetaMask. So MetaMask is an extension for your web browser that basically turns your web browser into a blockchain browser. So most, web browsers don't support connection to the blockchain out of the box. So you can basically just look up metamask.io. All right, that will give you a link to install MetaMask in your browser. If you're on Google Chrome or some other similar browser that has an app store for their extensions, you can just search for MetaMask if you want to, make sure that you're, doing the right one, and you can install it that way. You'll see that you'll have a little Fox icon in your browser whenever you get that set up. So don't freak out. This isn't actually real cryptocurrency. I wish I had $37 million just sitting there. But we'll see how to set this up later. Anyways, just make sure that you got this installed before we continue. Okay, so the first thing that we're going to create in this tutorial is the coin itself. Okay, so let me explain that. So in this tutorial, we have two different smart contracts. Okay, we're going to have the token Launchpad and then an actual token contract itself. So I'll show you that. We have that in the placeholders. So if you go to the project, you go to the contract directory, you can see there's a file for token.sol. All right, this is a cryptocurrency. And then factory, which is factory.sol. So the factory is basically going to be the Memecoin Launchpad contract. In fact, we can just go ahead and rename this to factory contract just to eliminate any type of confusion. So the factory contract, what it's going to be responsible for is letting other people create new tokens, right? That's why it's called a factory. A factory is the thing that produces new items. And you use the same concept in software development where, you have an entity that can create new entities. Well, this factory contract is actually going to be able to create new smart contracts on the blockchain, which are each of these coins. So these are tokens. So again, I can rename this from, coin 1 to token 1, coin 2, token 2, just to eliminate any type of confusion. So we're going to code out this factory contract from scratch, but what we need basically is a template for a token so that this factory contract knows how to create new tokens on the blockchain that other people can invest in. So that's what we're going to do right now. We're going to go ahead and create this token right here and create a template that other people can use for the factory contract. So how are we going to do this? Well, of course, we're going to do this with a Solidity programming language. All right. So the skeleton that you see right here is a Solidity smart contract. You can see contract token. We'll put all the code for it inside of here. Okay. You can see the Solidity programming language version at the top. And what we're going to do is create an ERC20 token. So what are these? Well, Ethereum basically lets you create new tokens without creating your own blockchain with smart contracts. And the ERC20 standard is basically just a standard that says how these tokens should work so that they are compatible with exchanges, they're compatible with cryptocurrency wallets, etc., etc. So what does this standard dictate? Well, it basically says that, the token must have a certain set of functions like name, symbol, decimals, total supply. It must have functions that let you read a user's balance. It must have a function that lets you transfer tokens from one wallet to another, like the transfer function. Let other people spend the tokens on your behalf, like on an exchange, that's transfer from, token approvals, allowance, etc., etc. And then it also must emit these specific events. So basically, any token that has all of these functions and these events is ERC20 compatible. Now, that being said, these ERC20 tokens that we're launching here are basically just template tokens. All right. So we don't have to reinvent the wheel here. We're not going to code out this entire ERC20 token from scratch. We're going to spend a lot more time coding out the custom logic of the factory contract. So what we're going to do is actually use a library to create a token quickly. All right. So what we're going to use is the OpenZeppelin library. So OpenZeppelin is a library that has a bunch of pre-made smart contracts that you can use and customize for your own needs, okay? So basically, they have a ton of different smart contracts. We're going to use this ERC20 token contract, and we're going to use this as a template. Basically, we'll just import the library, and we'll do some minimal customization inside of it in order to, just get started quickly. So in order to do that, we're going to do this in our web browser, okay? We're going to use a tool called Remix, which is an online IDE. Basically, it's a place where you can create smart contracts with the code in your browser. You can put them on a fake blockchain, and you can just kind of hand test them. I want to do this for a few reasons. One is to introduce you to Remix if you haven't used it before, show you how it works. Don't worry, we'll get back to all the tools in our computer that we just installed, like with VS Code and hardhat and all that type of stuff. But I want to just do this quick example here so that I can show you how to create the token and that we can just test it out by hand and make sure that it works, okay? So what you're going to do is go to remix.ethereum.org if you haven't already, and open this contract directory and click this little icon right here. This is create new file. And we're going to create a contract called token.sol, so capital T token.sol. That's the file extension for Solidity Smart Contracts. And inside of here, what you're going to do is go back to your code editor. You're going to find the code that's inside of this starter code, copy it, go to Remix, and paste it in there. All right, I'll bump up the font so you can see it better. But basically, what this does is, basic skeleton for the token. At the top, we have this license identifier. Don't worry about that. This is the Solidity programming language. It just says we're on version 0.8.27. And then finally, in order to create a smart contract, you use the contract keyword, all right, to say, hey, I'm creating a new contract. You give it the name, which is called token in this case. It's the same as the file name. And then you have these curly braces, and all the code for the smart contract goes inside the curly braces, all right? So there's nothing in here, but that's how you create the skeleton for a contract. Now, again, what we're going to do is just use the OpenZeppelin library to bootstrap a token. All right, you can kind of see how they do that. All we really need to do is import the OpenZeppelin library and then just add our custom settings in order to create this, okay? So what we're going to do is basically add this line to the top of our file, okay? You can type it out by hand, or you can get it from the final code solution if you want to. You can just look it up on GitHub, like I'll just show you. Let me find it here. You could go to the final code solution, go to contracts, and then go to token.sol, copy this line right here, go back to Remix, and then paste this in the top. All right. And if you really want to, you can copy this entire example straight from the final code solution. I just want to do this part quickly. We're going to spend a lot more time hand coding the factory contract. But you can go here. You can just go ahead and copy everything that's inside if you want to. Let's just go ahead and do that. I'll explain it. Don't worry, the entire tutorial is not going to be copy and paste. We're going to do a lot of hands-on coding. But this basically will get you started. So what we've done is we've imported the Open Zeppelin library for an ERC20 token. All right, we've created a contract called token. We said it is ERC20. That basically is inheritance. So it's saying like, hey, take all the behavior from this contract that you're importing and inherit from it. That's what inheritance is in software development. You're taking behavior from a different file and adding it to your current file, okay? So what we do in order to override this is we create a constructor function. Basically, this is the function that's run whenever the contract's created. We have some arguments, like we tell it who the creator is, the name of the token, the symbol, the total supply, okay? And we make the owner. All right, this is the person who owns the token, the creator, the person who created the token. And then we have the ability to mint some tokens. We're going to go ahead and set the total supply. So don't worry about everything right here. Again, we're just going to hand test this out and make sure it works. Okay. So what we're going to do is we're going to go to the Solidity compiler. We're going to make sure it's on the correct compiler version. Let's go to 2.7, compile the token. And then we are going to deploy. Make sure that you have Remix VM selected. And let's just see here. Make sure token contracts. And then now we're going to give it the constructor arguments. So for the creator, let's just take a random address if you want to. Let's just find a way to do that. If you go to etherscan.io, all right, pull up etherscan. Just find any address. You can click on a recent block, click on a transaction, find a from address, doesn't really matter who. We'll just put that as the creator. Say name can be my token, symbol MTK. And then for the total supply, what we're going to do is say 1,000,000 tokens. So we'll say 1, 1, 2, 3, 4, 5, 6. And now what we're going to do is do 18 zeros after that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I'll explain why we do that a little bit later, but let's just go ahead and do that for now. So click transact. And then we can see, boom, there you go. We have successfully deployed a token to the blockchain. Again, this is a fake blockchain that just runs in our browser. It didn't actually go to Ethereum or any other real blockchain like that. But you can see that we successfully created a token. It works. This code works just fine. All right. And basically what it does is we can call its functions. We can see the current balance. So you could just paste in that same address that you copied there, do balance of, call. So let's see here. Oh, actually, let's copy this one. Let's see here. Copy this address, which you could also use that for the creator address if you want to. Paste it in here. Now you can see that this address has all 1,000,000 tokens. This is the address of the wallet that you're using inside of Remix. So I just copied that with this little icon, and you can see that, yeah, they have all the tokens. So let's go over some basics about how this token works, all right? So let's revisit our diagram here. So for each token that is created, okay, the token is going to have a total supply. So again, I used the example of 1,000,000 tokens. Okay. Now, here's the first thing you have to understand whenever you're talking about cryptocurrencies. So inside of Solidity, okay, we don't use decimals at all. Okay, so when you're programming smart contracts, there's no decimal places. So if you express something like 1,000,000 tokens, let's say that you're going to do that in US dollar terms. Well, you have to express that with cents. Okay, so let's go to my text editor, show you this really quickly. Let's open up a new file here. So 1,000,000, 1, 2, 3, 4, 5, 6. If you were going to express that on the blockchain, $1,000,000, you need to express it in terms of cents. So a US dollar is worth 100 cents. All right. So $1,000,000 US on the blockchain will be 1,000,000, 1, 2, 3, 4, 5, 6 with 2 zeros after it. So you express $1,000,000 as, 100 million cents. All right. On the blockchain. Now, for cryptocurrencies like Ethereum and most Ethereum tokens, instead of 2 zeros after the decimal place, it's got 18. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So in order to express, one token with decimals, that's what it looks like. But to express one token without decimals, it's 1 followed by 18 zeros, okay? So similarly, if you're going to express a million tokens, 1, 2, 3, 4, 5, 6, you have to do a million plus 18 zeros after the decimal. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So yeah, it's a little bit cumbersome. We can program some of this in JavaScript later to make it a lot easier. I'll show you how to do that. When you're like hand testing things, like I just showed you Remix, you have to enter in the zeros manually. It's kind of a pain in the butt, but it's just is what it is, all right? That's because, cryptocurrencies that are very large need very fine subdivision. That's why we have 18 zeros after the decimal place. So in Remix, whenever we put in that amount here, all right, that's why. So that's one thing to understand about this token. So what are some other properties of this token? Well, this token is going to have two important people that are associated with it. The creator of the token, all right, that's going to be the creator of the token from the Memecoin factory, all right? So if we go back to our Remix example, you can see the creator here is saved. First of all, what we do inside the constructor function, again, this is the function that's run once and only once whenever the contract is put on the blockchain. We pass in an address for the creator, all right? That's what we did right here when we said, hey, we just found a random address, we put it in, we said, hey, this person's gonna be the creator, all right? We passed in that here. That's this address right here, okay? So next we give the token a name and then the token a symbol. All right. Oh, before I say that, sorry, the creator, let me show you that we basically save that creator to a state variable. Okay. So that's the state variable that we declared here. So address public, that means that this variable can be read outside the contract. That's why we have this nice function for it, creator right here. And basically that says like, hey, we're saving this creator. We can read that value out of the contract. That's why we have this blue button to read it. Basically, all these yellow functions are write functions. All these blue functions are read functions, okay? And that's the creator. So anyways, we also, whenever we create the contract, we pass in the name and the symbol, which you can see here, my token, and then MTK. These are just part of the ERC20 standard. Every token has to have a name and a symbol. And then finally is the total supply of the token, okay? So basically, that just means how many coins are going to be in existence. So in this case, we just passed in 1 million, of course, followed by 18 zeros. I explained that a second ago. And what you do is you actually call the mint function. So the mint function, what this does is it creates new tokens, okay? It comes from the Open Zeppelin library. That's where the mint function comes from. And basically, we're just minting tokens at the time of token creation, and it puts 1 million tokens into circulation. Now, of course, they're not in circulation. They only exist right now on the factory Launchpad, and whenever investors buy the tokens, they'll get, these tokens whenever it successfully launches. Okay, a couple of final things I'll say about this contract is that whenever we mint tokens, we only mint them once, and that's whenever the token is listed, okay? Because again, the factory contract is the one that's actually creating the tokens. So it's just going to create tokens whenever it, deploys this contract from the factory contract. And then finally, who is the creator and who is the owner? Well, of course, the creator is the person who is listing the coin on the factory. So that's the address that's going to get saved here. But who is actually the owner of this token? Well, the owner in this case is going to be the deployer. All right, so that's what this message.sender stands for. We'll explain that more when we get into more custom coding. All right, but the message.sender, in this case, the deployer, is actually the factory contract. Okay, so the owner in this case is going to be the smart contract address of the token factory, and then the address for the creator is actually going to be the address of the person who listed the token. All right, so then finally, the one thing I want to say is, we showed how to import a library, how to inherit here, but how do we actually pass in the settings to this contract first for our token's name and symbol. Well, that's what this ERC20 is here. We're basically just saying, hey, take the constructor function for the ERC20 token here, apply it, and then pass in the name and symbol that we have here to this, and then boom, there you go. It's going to create the token. Now, I know we kind of just copied and pasted all this. I just kind of did an overview of the code, but we verified that it works. We're going to do a lot more custom coding in the next section, but I wanted to just show you how to basically get all that started quickly and explain some basics. Okay, so now let's actually start doing some step-by-step coding. So what we're going to do is we're going to start creating this factory contract right here. So again, going back to our diagram, we're going to create this factory that's going to let people list tokens. It's going to spit out new ones. It's going to let investors purchase them, and then it's going to handle basically all the Launchpad behavior. So the first prerequisite step is we want to go back to Remix. All right, copy all that code, or you can get it from the final code solution, whatever you want to. I'm going to go ahead and close Remix down because we're not going to need it anymore. All right, and then we're going to go back to our VS Code. We're going to go to the token. All right, we're going to paste all that in there. All right. I'm just going to minimize this a little bit so you can see it. I'm going to do a empty space at the end, carriage return. And what I'm going to do is actually open up my terminal, and just as a quick sanity check, I'm going to make sure that it compiles. All right. So I'm going to do npx hardhat compile. And you can see that it successfully compiled the contract. There's no code issues. It's not an official test or anything like that. But I just wanted a quick sanity check to make sure whenever I imported this into hardhat, there was no issues. So go ahead and clear that out. All right. So now we've got this token contract, and we can start working on this factory contract so that other people can create them. So inside of here, what we're going to do is we have our boilerplate set up. We've got the Solidity programming language version declared at the top. We have the contract keyword for factory. All right. And then we have these curly braces. We can, hit enter. I'm going to put all the code for the factory contract inside of here. So the first thing that we're going to do is talk about state variables. All right. So what are those? Well, state variables are basically a variable inside of a smart contract. So what is a variable? It's just a placeholder for information that can change. All right. But it's a variable inside the contract that you can assign a value to, and that value is actually going to get stored on the blockchain. Okay, it's going to be different from a local variable. We'll talk about that in a minute. But basically, how do you create a state variable? Well, you just put it inside your contract here. It's not inside of a function or anything like that. You just write it, at the top, and you can, do something like, give it any value. I'll just do this for example. So you can do string public name equals factory. All right. I'm going to put a semicolon at the end. Every single new line inside of Solidity needs a semicolon. So basically what this does is I create a new variable called name. All right. I tell it it's the data type string. So Solidity is a statically typed language. Basically every variable has to have a specific data type. In this case, it's a string. So we say that first. String is just basically a string of characters inside of a quotation marks. That's the value right here. We give it a name. We tell it it's of type string. We assign the value with this equal operator here. And then we give it the value of string factory. And we put a semicolon at the end. So finally, what we do is we call it public name. All right. And then what that does is it basically lets us read the value of this variable outside the smart contract. So if we write an app, we can access the value of this variable. If we write a test, we can access the value of this variable. So what we're going to do is go ahead and write a test for this. So that's how we're going to create these smart contracts. What we're going to do is create the contract first. We're going to create the website second. We want to finish all the smart contracts, before we start coding at the website just to make sure everything's done. So, you could, whenever you develop a smart contract, you could do it inside of Remix, right? Like I showed you, you could code everything out. You could hand test it, but that's going to get really cumbersome. Okay. because every single time you make a code change, you're going to have to go back through and make sure everything else worked properly. But what we're going to do is actually write tests for the code, for the Solidity code in JavaScript while we're writing the Solidity. All right, we're going to do that for several reasons. So number one is testing is incredibly important for smart contracts. So you have to understand these don't work like other programs. They're blockchain-based programs. They are immutable, which means the code can't change. So whenever you put it on the blockchain, you can't update the code if you have a bug. Therefore, you want to make sure that the code is right before you actually put it on a blockchain. So testing is very, very critical. So we can actually write automated tests inside of JavaScript alongside our Solidity file here to make sure that the Solidity code is always working. So what you can do inside of here is you can see this boilerplate code for a factory test. All right. So basically, hardhat comes bundled with some libraries like Mocha and Chai. All right, to help you write tests. It's also got some helpers for like fixtures inside of here. So what we can do is write tests for the factory inside of here. So for example, we can say describe factory. Basically, that's just saying, hey, here is a contract called factory. We want to describe all the behavior for it inside of here. So what we're going to do first is basically just check that the factory has a name. That's the only behavior we've written so far. We'll go ahead and save this. All right. And so I'll write a test example that says it, all right, should have a name. Okay, so we have an it function. So this it function accepts a string, which is just the type of test. And then we can pass in a function, say async function. So inside of here, what we're going to do is we're going to check to see that the contract has a name. Check name. All right. But there's actually a prerequisite step that we have to do that before we can even check for the name. So we must first deploy the contract, right? And even before that, we have to fetch the contract, because you have to understand this test is a blank slate. We have to program every single thing that we want to do. So first, let's fetch the contract. Basically, what we're going to do is load up the contract in JavaScript. Not even the deployed contract, just the contract's code itself, just the Solidity code that you see right here. So we're going to do that like this, say const factory, capital F factory equals await, ethers, get contract factory. And then we're going to call it factory. Okay. And then we're going to deploy it and say const lowercase factory equals await capital F factory deploy. All right. And then finally, we can check the name just like this. We can say const name equals await factory dot name. And then let's do console.log and name. All right, so let's just go ahead and run that. That's not an official test, but let's see if we can get that far without any issues. So I'm going to open my terminal. Okay, I'm going to pull this down a little bit. And I'll pull this up. And I can say npx hardhat test. This is how you run the test in hardhats. npx is the command that says, hey, I'm going to run a node module command, or node command, but I want to do it with the libraries that I have installed inside this folder, not my global node modules folder. Okay. So you might see like npm hardhat test. Well, npx is different because it does it from the context of this particular project, not in your entire system. So, we installed hardhat as a project dependency, so we're using this version of hardhat here. So npx hardhat is the executable that comes with hardhat, and then test, of course, is the test command that's going to run all the tests inside this folder. So hit enter. We might have some errors, so let's just see. Oh, it works first time. So you can see the name is logged right here. So fact. So finally, we can actually, check that name is right. Name is correct. And we do that like this. Basically, we'll just say expect name dot two equal factory. All right, let's save that. We're going to test again. And then boom, it passes. The console logging statement's removed and it has a name. Okay, so let me just minimize the font a little bit. You can see that better. So that's our first test. All right, we basically, wrote this basic smart contract that doesn't really do anything. All it's doing right now is has a variable. But again, this is a state variable. It's a value that's actually written to the blockchain. We saved the value, the name to factory. It's a string. We made it public so that we can read it outside the contract. That's why we're able to actually inspect this value into our test. And then you kind of see how tests work. Basically, you write describe the contract that you're doing, and you are creating a test example for each bit of behavior that you want to with this it function. All right, and you can say, hey, it should have a name. That's what gets logged out here. And then you pass in the function of the actual code you want to run. We fetch the contract from hardhat. We deploy the contract to the blockchain, and we check the name. And we check that the name is also correct with this expect function right here. So there's a couple of other things that I want to mention before we move on. One is you see this async here and you see this await. All right, so what the heck is that? Well, whenever you are dealing with the blockchain, it's kind of slow, okay? So JavaScript has a way of dealing with this. It's called asynchronous programming. I'm not going to get in depth on how that works in this video, but basically, if you took this await keyword off of there, this is probably not going to work. Let's just see here. Yeah, it's not going to work. Okay. So why is that? Well, basically, anytime we're talking to blockchain, we're typically going to use an async await pattern because these functions that do that, they're asynchronous, which means that if I took this off, this line would just keep running and it would move to the next line of code before this is actually finished. So basically, like if I tried to deploy the contract, this wasn't on here, it would just say, hey, deploy the contract, but it wouldn't actually wait for the contract to finish deploying before it moved on to this line. So if we did this, we would try to check the name for the contract before it's even on the blockchain, which we don't want to do. So therefore, we use this await keyword. Okay, you can look up how JavaScript promises work. There's lots of different ways of doing it, but async await is the most common way for this type of development. I don't want to get into the weeds in that, but that's why you're seeing await here. Now, finally, if you're going to use the await keyword on your functions, it has to be in the context of an asynchronous function itself. So that's why we have this async function here. You couldn't just like say, await, my function here because you're not inside of an asynchronous function itself. So that's why you see the async here and then await, hence the async await pattern. Now, the last thing I'll say here is we're going to be doing lots of stuff over and over again, all right, inside of our contract. Let's just have another thing called name2, factory2. Let's write another test. Let's copy and paste it. Let's see here, another name. All right, factory, name2, factory2. Let's run that test. All right, it works. So basically, we're going to be writing multiple tests to check for behavior. And you can see there's a problem with my code. I have all this duplication, all right? I've got this test here that deploys the contract, okay? And then I've got this test here that also deploys the contract again. So we don't want to deploy the contract over and over and over again, okay? So how can we fix that problem? Well, inside of hardhat, we can use these things called fixtures, okay? So if you watch my older tutorials, you might have seen me use something like before filters or before functions, something like that, before each. So that's kind of changed a little bit with hardhat, all right? They don't use that as much anymore. You still can, but they do it in favor of fixtures. So fixtures basically let you run your tests faster than before each functions. But basically what we want to do is create a way to abstract this code so that we don't have to repeat it all the time. So what we're going to do is create a fixture for this. So we do that like this and say async function, deploy factory fixture. All right. And then what we're going to do inside of here is we are basically going to just take this right here. All right. We're going to basically take the factory. Okay. And we're going to take this out of here. So this removes the duplication. And then what we're going to do is return the values that we might want to use in our tests. Say return. Well, we don't really, return factory. Okay. So then inside of our tests, what we can do is for the variables we need, we can say const factory. This is called destructuring and inside ES6. Let's see here. Deploy factory fixture. Okay. So what this is going to do is return all the variables that we need, and we can access those variables right here. And we need to do await. And now, if we copy and paste this to both test examples, we should be able to run that without any problems. Let's just see. Famous last words. All right, it works. So you can see that basically the test works the exact same. And what we did was reduce the duplication instead of having to deploy the contract every single time. We get it for free inside this factory. And why you do it in the factory rather than before each is that it actually saves it to the state. So you can see this first test took a little bit, right? But once that's loaded, it's able to just reuse that exact same information over and over again without having to do it a bunch of times. So that's how you use the fixtures. That's how you reduce the duplications on your tests. And we'll build on this more and more as we continue on coding out the project. So that's an introduction to, creating your first smart contract and actually writing a test so that we can do that. Now, that being said, we're going to blow away some of this code because we don't actually care about that. I'm going to go ahead and minimize my terminal here so that you can have a little better view of what I'm doing. But I'm going to go back to the factory. We're going to take out these state variables. I just want to introduce you to what a state variable is, okay? And we're going to go ahead and blow away these test examples because we don't actually need them, all right? But I want to show you basically how to get the test working. So the first thing that we're going to do is code the smart contract and actually set the fee. So again, what's going to happen is the developer who deploys this contract is going to get paid anytime somebody lists a token. So when a creator creates a token, like token 1, token 2, the developer is going to get a fee for doing that. So let's go ahead and code that into our contract. We can use what we've already learned, state variables, to do that. All right. Let's go back to our factory. And let's look at how we're going to do that. So basically what we can do is say, we can create a state variable here, but instead of a string, it's an unsigned integer. So uint 256. That just means it's an unsigned integer of 256 bits. But it's an unsigned integer. It's a number without a sign. So a sign is like a negative number. So it's a non-negative integer. I have 256 bits. That just means it can be very large. And we will create this fee as, uint public fee. We'll create this as a variable. So normally what we could do is say the fee is 3 and then put a bunch of zeros after it. We could hard code it just like we did with the previous example, but what we're actually going to do is assign this value inside the constructor function, okay? So what is the constructor function? It's the function that's run once and only once whenever the contract is created. So you can create a constructor with a special keyword like this, just say constructor, okay? And then what we're going to do is pass in an unsigned integer, uint 256. We have to give it the data type of the thing we're passing in and do underscore fee. And then inside of here, we can set this fee right here, fee to equal the fee that's passed in, okay? So basically what it's going to allow you to do is whenever you deploy the contract, you can assign an arbitrary fee and it'll save it on the blockchain just like this. So let's go over a couple of things. So this right here, this uint, this is an argument for the function. Basically, whenever you run the function, you can just pass in this value. So we give it a data type of underscore of uint256, and we say it's a fee variable. Now, this fee right here is an underscore inside this function. It's a local variable. Okay, this is a state variable. This is a local variable. So what does that mean? Well, basically, the state variable is written to the blockchain. You can access it anywhere inside the smart contract, but this local variable is not written to the blockchain. It's just temporary whenever this function's run, and you can't access it anywhere else inside the contract. You can only access it inside this function call. So you can't access it here. You can't access it in some other function you create later. It's only accessible inside this function constructor, okay? And so what we do is just assign this fee that we passed in to this state variable here. Now, why is there an underscore? That's just to denote that it's a local variable, in this case, a function argument, okay? You don't actually have to use those. We just do it to avoid confusion, especially since you have two things that are the exact same name, and it's also semantic to say that this is a local variable or like a function argument, okay? Just so that you can see like what's getting passed in versus like what's, somewhere else in the contract. So the last thing we can do is change this state variable slightly. We can actually apply this to it. We can basically say that the fee is immutable. Okay, immutable means it can't change. So whenever we set the fee, it's basically going to be a constant. Nobody should ever be able to update that fee. It should be a constant value. All right. So let's test this out. Let's go back to our factory. So inside of this deploy factory fixture, we have this deploy function here. This deploy is going to run our constructor function. Okay. So whenever we do that, we actually have to pass in the value that we want for the fee. All right. So we'll do that just like this. We'll make the fee, let's make the fee 0.01 ether, okay? Now, you can't use decimals, again, like I was saying. So what you can do is this. So I can just do a variable here. I could say const fee, all right? And I could say ethers, parse units, and do 0.01 inside of a string, and then say 18. So what that's going to do is it's going to take 0.01 ether, all right, and it's going to convert it to the non-decimal value and specify that we want 18 decimal places, okay? And then I can simply pass in the fee here, all right, and that's actually going to make it work. Now, that being said, we're going to use this fee other places in the test. So instead of putting it inside this factory, what I can do is actually put it here at the top of the file. Outside the fixture, so we can reference this in other places, and I can just deploy it right here. Okay. And then next, what we can do is we can create a place to describe deployment. Do that like this. Basically, we can say describe deployment. Again, you can nest your test examples. So I know we did it before, but now what we're going to do is say describe a factory. We're going to try to describe a certain set of behavior, which is the deployment. All right. So we're going to say it should set the fee. I'm going to paste that in there. So we use the it function. It should set the fee. We do an asynchronous function. All right. So to do that, what we do is we load our fixture. So like I did before. We say const factory equals await load fixture, deploy factory fixture, just like we did in our previous example. And now we can check to see expect await factory.fee. We want that to equal the fee that we've done right here. So this is the fee. We're going to read it down here, and we expect the factory fee to equal the same thing. So let's run our test and see if that passes. Okay. And then boom, there you go. It works. We have the fee set, and it's testing for it properly. Okay. Awesome. So the next thing that we're going to do is check for one other thing inside of the fee. Inside the deployment. Okay. So the next thing we want to add to our factory contract is we want to have the owner. So we want to track the developer who's actually made this, because again, who is getting the fees in the first place? Whenever somebody lists a token, the developer who created the contract is going to get a fee. So, we could call this person developer in the contract, but instead we're going to call them the owner. That's a very common thing to do inside Solidity is say who is the owner of this contract. So we're going to create a state variable for that. Okay, so we have a state variable for the fee. What we're going to do is have another state variable for the owner. This is a value that's going to get written to the blockchain, but the type is not going to be a string like which we all saw before. It's not going to be a number. It's going to be a blockchain address. So we say address public owner. So basically that's just going to save who the owner of the contract is. Now, the cool thing about this is we do not actually have to pass that value inside the constructor, because we know that the developer is going to be the one who's deploying this contract. So we can read the value of the developer's wallet address from the transaction itself. Okay. So how would you do that? Well, I'll show you like this and we'll explain it. Owner equals message.sender. Okay. So what is that and how does it work? Well, message, anytime you make a transaction on the blockchain, you're sending a message. So inside Solidity, you have access to this MSG, which stands for message, global variable inside your contract. And it's got all types of values that can read from it, like message.value, which we'll talk about that later, but message.sender is just the person who's sending the transaction. This is a blockchain wallet address, who is calling this function basically. And in this case, it's the deployer, the developer, because they're deploying the contract, they're calling this constructor function, and we can save their address right here. We can write it to the blockchain with this state variable, and it'll get saved to the blockchain forever, and it won't change. Okay. So we can check for that in our test like this. Basically, we can just load up the exact same fixtures, write our test example that just says it should set the owner. All right. Should set the owner. Load up the fixture factory just like we did here and say expect await factory owner to equal deployer.address. Now, we don't actually have a deployer yet. Okay. So how do we get this deployer.address? Well, we need to actually read it from the blockchain. Okay. So this is where we're going to see ethers.js come in a little bit more. We saw ethers here, okay, when we did the parse units, but let's just revisit ethers for a second. So again, ethers is the JavaScript library that we can use to talk to the blockchain. We're going to be using ethers a lot. We just use a little utility to convert ether values. Basically, what you can do is you can get wallet addresses. So we can talk to our hardhat environment, get the wallet addresses, and see like, hey, who are the wallets that are connected, et cetera, et cetera. So I'll show you how to do that right now. Basically, before we fetch the contract, we get this preliminary step. We could say fetch accounts. Okay. And what we can do is call this function await ethers get signers. So what are signers? Well, signers are just like fully fledged wallets that can sign transactions. But this is basically like how we get the different people who are connected to our hardhat project in this case. So let me just do this. Let me comment out this test for a second. And let me just do console.log. Let's do this. You'll see what's in there. Okay. You can see like all these different things were in there. So you can see there's a list, there's some repetition in here, there's all the individual signers. This is all the different addresses that are connected. So you can see like, here's a signer, here's a signer, here's a signer. These are JavaScript objects, but they actually have addresses inside of them. So this is the actual address of the deployer. It's the first one in the list because I think there's 20 on this list. Okay, the first one is the deployer by default. So what we can do is those are an array. We can break those out of the array in JavaScript like this. We can basically just say const and then give it an array and then do this and say deployer. All right. And then what we're going to do is export the deployer as well. Okay. And now we should be able to make this function work. All right, I'll let you pause out on your screen. Let me, I'll show you this block and then I'll show you the factory. Well, let's just start with factory first. So if you want to pause that, make sure it looks right. Okay, if you want to pause this and make sure it looks right. Okay, so now let's run the test and see if it passes. All right, so they both work. So we set the fee and we have set the owner. All right, that's good first progress. All right, so now we have created the basic factory contract. We've deployed it to the blockchain in our tests. We've written some tests to set some basic behavior and actually check on that. We have set the fees, and we've also set the owner of the contract as the developer. Basically, we set up all the infrastructure for the developer to make sure that they get paid a fee whenever we list coins. But now let's actually get onto listing coins. We're going to create the behavior where anybody on the blockchain can go to the factory contract and actually list a coin from scratch. Basically just create a new one, give it a name, give it a symbol, and then put it on the blockchain, okay? So that's going to require a function. So we have talked about state variables. We've talked about constructor functions here, but now we're actually going to talk about, coding our own arbitrary function inside Solidity. So how do you do that? Well, you use the function keyword, function. Okay. And then you give the function a name. In this case, we're going to call it create. And then you use these parentheses here. And then you use these curly braces. And inside of these curly braces is going to be all the code for the function body. So what are we going to put inside this function? Well, it actually has to do quite a few things. So the first thing that it needs to do is create a new token. All right. On the blockchain, it needs to save the token for later use so that we can actually, fetch it later inside this contract. All right. And it actually has to list the token for sale on the platform. All right. And then finally, we need to tell people it's live. Okay. So there's several things that we need to do here. So let's start off with creating the token. So again, this token Launchpad is what's called a factory contract. It is a smart contract that can actually create new smart contracts. Okay. So going back to our diagram, creator comes to this, they call this function, and it spits out new tokens. So each of these tokens are going to be new smart contracts. So don't forget, we already created the token smart contract here in Remix. We just kind of copied and pasted this to get up going quickly. We're doing all this stuff step by step, but we can actually import this file, okay, into this file here like this. Basically, we just say import token from ./token, okay? So just add that to the top of your file, and that will get all the code for this inside of here. Now, this is not going to put a new contract on the blockchain. All it's doing is importing the template code so that this contract can actually spit out new deployments of this particular contract and use this as a template so we can do it over and over and over and over again anytime somebody calls this create function. So how do we do that? Well, to deploy a new smart contract inside of Solidity from a different contract, you do that like this. All right. Basically, you're going to say capital T token. All right. You have to use the data type. Okay. Token, and then lowercase token is the variable name. All right. Equals a new capital T token. And then we're going to, of course, put in the arguments that are required in the constructor function. But that's basically it. This new keyword token is going to instantiate or create a new token from this template here. So you use this capital T token. That's what's being referenced here. That's the data type that you see here and here. We're going to save it to a local variable called token right here whenever we create it. But then we also have to pass in the arguments. So again, what do we need? Creator, name, symbol, total supply. All right. So for the creator, we can do message.sender. Because again, the creator is the one who's calling this function. We talked about message.sender with the constructor. In the constructor context, that's the deployer. In this case, it's the creator. So message.sender is the creator. Okay. The name. Okay. Well, how do we want to get the name? Well, we want to get the name from this function. So we can say string memory name as an argument and then pass that in here. All right. And then we also need to get the symbol. So we can say string memory symbol and then put that here. Okay. And then I can also clean this up by putting these on new lines. Okay. And then finally, we need the total supply. So you can do that like this. 1 million, we'll make it 1 million tokens every single time, just like we did in our previous example. But instead of having to type out 18 decimals after this, Solidity has a nice thing where you could just say ether. And if you say ether, it's going to give you the same number of decimal places, which is ether, which is 18 zeros. So if I just do a million and do a million ether, it's going to give me a million with 18 zeros after this number. That's a really nice shortcut. Okay. So that is how we create a new token. All right. So we can actually write a test for that. But before we do, we need to save this token for later use so that we can actually reference it on the blockchain and inside of the application and inside of a test. So what we're going to do is create an array. All right. So if you're not familiar with an array, what it is, basically it's just a list of elements inside some brackets like this. So, if it was just strings, I'm just doing some pseudocode here. All right. You could say like, token 1, comma, token 2, comma, token 3. This isn't correct Solidity code necessarily. I'm just kind of showing you. Basically, an array is just a list. We want to have like token 1, token 2, token 3, all inside of here. So we want to save this array on the blockchain. So we're going to create a state variable for it. So up here, all right, below these state variables, we can create an array like this. Basically, we're going to say address, open bracket, public, tokens. So what is this? So basically, this is creating an array with these brackets right here. We have to tell it which data type is going to be inside the array. That's why we use the address right here. So this is an array of addresses. It's going to be called tokens. That's the name of the variable for this array. And it's going to be public so we can read it outside the blockchain. So now we're going to have this array kind of like this that we created here. And we can actually store tokens inside of it with push command. So push basically just adds a new element to an array at the end. So if we call push, token 4, that would put a new token right here. All right. So I'll show you how to do that with Solidity. Basically, we can just say tokens.push and do address token. Okay. Now we've created the token and we saved it to this array so we can read it for later use. This is just the address of all the tokens that we've created on the platform. And then finally, what we want to do is get a quick count of all the tokens that are on the platform. Okay. So we can create a state variable called total tokens and say uint 256 public total tokens. And that's just going to be like a counter cache. It's just going to tell us how many tokens there are on the platform. And we can quickly access that number. So we'll just say total tokens. By default, it's going to be 0. So we could say total tokens equals total tokens plus 1. All right. But there's a shortcut for doing this inside Solidity. If you want to increment a number, basically just add 1, you can use a shortcut like this, plus plus. And that's going to just increase the value by 1. All right. So now in the create function, we've let a user create a new token. We saved it to an array so we can access for later use. And now we know how many tokens have been created on the platform. So let's go ahead and write a test for this. Let's close down this token. We're not going to need that anymore. Let's go to the factory.js and let's create a new section. So we've described deployment. Sorry, let me kill that. We described deployment. Let's go ahead and describe, creating tokens. So we can have a new describe block here that is said describe creating. We can close that out. And for our first test example inside of here, we can basically just say it should set the owner of the token. So it should set the owner. All right. So inside of here, I'm going to write the code for that. Basically, we're going to load our fixture. But in order to do that, we need to update our fixture first. Okay. So all we've done now is we've got the deployer. We fetched the factory. We need to do a couple things. First, we need to have a new address for the creator. All right. So we say creator here. So fetch accounts, deployer, creator. We're going to return the creator here as well. And then what we're also going to do is we're going to actually create a token. Okay. So we'll say create token. And so we're going to say const transaction equals await factory connect. And we're going to call the create function right here instead of our fixture. We're going to connect the creator account. And I'll explain more of this in a second. Create a new token. Let's call it Dapp uni token. And then we'll give the symbol Dapp. And then for the value, we need to pay the fee. Okay. So let me kill this sidebar so you can see that better. I'll come back and explain some of this in a second, but let's go ahead and do that. And then we're going to do await action await. And then down here, we're going to basically load that same fixture. Like this. Say const factory and the token equals await load fixture, deploy factory fixture. And then we're going to expect the owner is correct. So expect await token.owner to equal await factory get address. So there's one more thing we need to do here. We need to get the token address as well. Get a token address. And we'll do it like this. Say const token address equals await factory. We can read all the tokens from the array. All right. Because the array is public. It's right here. Tokens And we can get the first one in an array, which is 0. So arrays are 0-based index. The first one is 0. The second one's 1. Third one's 3. It's kind of confusing if you're new to programming, but that's how it works. And then we can actually get that token. Say const token equals await ethers get contract at and token, and then token address. So this is the token address, and this is the actual token contract itself. So we can return those here. And say token, and then deployer, and then creator. All right, so now we have factory and then token. So what we're going to do is expect the token owner, all right, each token has an owner, to equal await factory address. Because again, don't forget, the factory is the one who's creating the tokens. The creator lists it, the factory creates it. So the owner of the token should be the factory, and the creator should be this address. Okay, going back to our token. I said we wouldn't need it, but let's look at it again. We've got an owner and a creator. Again, the owner is the person that's calling the function. That's the factory. And the creator is just passed in here. And we pass in the creator as the person calling the create function. That's this message.sender. Okay. Now, I think that's everything that we need. Let's just run the test and see if it passes. Fingers crossed. All right, so we got a little bit of an issue here. Let's just go ahead and fix that. So let's see here. No visibility specified for create. All right. So we need to fix that. So basically, just like our state variables have visibility, so do our functions. So for create, what we need to do is make this external. All right, so it's still not going to work. I'll tell you why in a second. Let's run it, see the failure, just so I can show you how this works. All right, so now it's saying, non-payable function was called with this value, non-payable. So what does that mean? Well, if you go back to our example, inside the factory.js, you can see this line here. So we created a token, we passed in these arguments, the name, the symbol, and then we have this metadata here. So metadata is just like non-arguments that are passed into a function. So you see, I'm passing in value here. So there's no, you don't see a value argument in the function. That's because it's function metadata. So basically you can pass in different metadata into a transaction, in this case value. So value is actually some ether that's getting sent in with the transaction. So basically how it works is the creator, whenever they call this function, they're going to call it, but it's actually going to require a fee. That fee is getting paid in ether. It's passed into the transaction, okay? And we express that as the value metadata, and that's going to say the fee. So basically we pass in value, that's going to be some ether amount, 0.01 ether, and that gets passed in with the function call, okay? So in order to actually send in cryptocurrency, ether, with this create function, we have to make it payable. All right. A payable function is one that you can actually send Ethereum cryptocurrency or ether when you call a function. So it's going to call the function plus take some cryptocurrency out of your wallet to pay for it. So it is a payable function. Now, where's the ether going to go? It's going to go straight into the smart contract. And we'll probably write some tests for that here in a second as well. But that's why that error was saying, hey, non-payable function. Now the function is payable. We fixed it. All right. So I fat fingered this. Let me just fix that. All right. And then boom, there you go. It works. Okay. So the last thing I'll say about this is on this line here. Let's go over this again. So whenever we're creating the token, we're creating a transaction. So we're calling a function on the factory. And we want to do that from the creator's perspective. So here, like we did factory, if you're calling something, you want to specify who the wallet is, you do connect and you pass in the signer. So in this case, we want to pass in the creator. So we have factory connect creator. That means, hey, we want the creator to call this function and call the create function. We just chain it like this. And we pass in the function arguments, the name of the token, the symbol, and of course the function metadata, which is the fee because the creator's paying a fee to do this. We want to wait for the transaction to finish. So we do await transaction wait. If we didn't do this, Again, it wouldn't wait for the transaction to finish before moving on. We want that to happen before we move on to the next step. Then, of course, we fetch the tokens array like this, and then we get the token for later use. All right. Okay, so now it sets the owner. So let's just see. It should also set the creator. Okay, so let's just write a quick test for that. We got a lot to cover, so I'm just going to drop this in here. All right, you can pause this and copy it down if you want to, or you can go for the final code solution. Basically, we just want to make sure the creator is equal to the creator address. Let's save that and run it. All right, so it does set the creator properly. All right, it should also set the supply. Let's drop this in here. Okay, it should set the supply. Let's run that. Oops, I put that inside the wrong place. Let's pull that out. See that again. Oh, I didn't put it inside of creating. Let's try that again, everybody. So inside of creating. Sorry, it's hard to see with my VS Code with the font so big. Let's just do this. Save that. All right, there we go. So that's the supply. So basically what we're checking is making sure that the total supply of the tokens is correct. All right, that's 1 million tokens. And then finally, it should also update the ETH balance. All right, so let's drop that in and I'll explain it. Drop it in, make sure it passes, and boom, it passes. So let's explain that part. So basically, again, whenever these tokens are listed, they're going to go, the creator's going to list them, they're going to pay an Ether fee, and that fee, of course, the developer can get it. Now, it's not going to go straight to the developer, okay? What it's going to do is it's actually going to sit in the factory contract, okay? So the developer can withdraw it later, but the ETH balance is actually going to go to the factory contract, okay? And then, so how do we, so inside Solidity, basically, you don't have to write any special code for this. It just sits inside, well, yeah, it just sits inside of here. And then we'll write code later to withdraw it. But you can check the balance like this. Basically, you say balance equals await ethers provider get balance, and then you just pass in the factory address, and we just make sure the factory address is equal to the fee. So the person just paid the fee. We want to make sure that that fee is actually stored in the contract, the balance is correct. And that's exactly what we did here. We ran that test and it passed. Okay, so now we have created a token. We have saved it to the smart contracts. We can access it later, and we can also fetch the total tokens count. All right. So now what we want to do is actually create a way to list the token for sale, because all we've done is deployed a new token to the blockchain. It's not for sale yet. We're not letting people buy it. But in order to let people buy it, it actually has to be listed for sale. Okay. So what we're going to do is we're going to create a token sale inside of our smart contract here. So we're going to model this with code. All right. So we're going to do that with something called a struct. Okay. So basically, Solidity is a statically typed language. It's got all these different data types and data structures. You got arrays, you've got numbers, you've got strings, you got all the type of stuff. But you can create your own arbitrary data structures with something called a struct. So we can use a struct keyword, and we can say token sale and use these curly braces. And what this is going to do is basically just let us create an arbitrary data, folder basically, or data, model of what a token sale should be. So we can give it just a bunch of attributes. So if you're a JavaScript programmer already, this is kind of like a JavaScript object. Or if you're in another, programming language, you probably have objects or something like that, or like, hash tables or, stuff like that, right? So basically, we can give it a bunch of attributes like this, like address, token. All right. String name. All right. You do each one with a semicolon after it, and then add all these other attributes just like this. I'll just drop them in there. Okay. So basically, this is just modeling a token sale and all its various attributes. This doesn't actually create a new one. This is just like a template, our own template data structure. So that when we want to create a new one, it's going to have all these attributes. So like a token sale's got a token. That's going to be an address. It's got a name. It's got the creator address. It's got how many tokens were sold in the sale. It's got how much ether was raised in the sale and whether the sale is open or not. Okay. So again, that doesn't create one. It just gives us a template to create one. So how do we actually create one? Well, we're going to do it inside Solidity when we list the token for sale. Basically, what we're going to do is just say token sale, and then we're going to pass in all the attributes. Let's just copy and paste them here so we can see what we're doing. I'm going to comment them out. So when you get all these attributes, so the token address is just going to be address token, all right, which is this token right here. Okay, you can do this all in one line. I'm just going to break it up onto multiple lines just to make it easier to read. It needs a name right here. So that's going to be the name that's passed in from here. Okay. It's going to need the creator, which again is message.sender. So message.sender. It's going to need how many tokens were sold. So whenever we create it, it's 0. How much ether is raised is 0 because nothing's happened yet. And then is open, this final value here, is going to just be true. All right. So that's all the attributes when we create a token sale. Now, in order to list it for sale, we need to save it to a variable. So we just say token sale, memory sale equals this. Okay. So we saved it to a variable, but now we need a place to actually save it. Okay. So we've created a template for a token sale. We've created a new token sale, but we actually need to save it to the blockchain. All right. So, because all we've done is created it in memory right now inside this function call. We haven't actually stored it on the blockchain. So in order to store it on the blockchain, we need a place to do that. And so that's exactly what we're going to use a mapping for. Okay. So I'll explain what a mapping is in a second, but let's just go ahead and create one inside of Solidity. All right. So let's do this. Let's copy down this line and I'll explain it. We'll say mapping, keyword. We'll say address. And then a little rocket, token sale. We'll say public, token to sale. All right. So let's quickly explain what a mapping is inside of Solidity. So I'm just going to pull this off. We'll look this up here. All right. So let's talk about a key value store. So what is that? So a key value store is something that's used pretty commonly in programming. Okay. So basically, let me just pull up the image I saw a second ago. Yeah, right here. So what is a key value store? Well, you can kind of think of it like an Excel spreadsheet or like a traditional database if you're coming back from programming, or like some other data structure inside of a different programming language, like an associative array, something like that, right? Basically, a key value store is where you have a key, basically like a lookup, where you have a key that is unique and it corresponds to one and only one value. So basically, right here, you have a K, like key 1, that corresponds to value, all right, which is this value, key number 2, which corresponds to this value, key 3, which corresponds to this value. So said a different way, like inside of code, let's just open up a new thing here. You could say like item 1, corresponds to this value, apple. Item 2 corresponds to banana. All right. item 3 corresponds to this value orange, right? Or caret, if you want to go with alphabetical. Okay. And this could be anything, right? So that's what a key value store is. In a database, it's a similar type of thing. You don't have this item prefix. All right. It's just like 1, 2, 3, like in a regular database. And 1 can't be multiple things. It's unique. It can only be one thing. All right. You could update it later. You could say zebra if you're able to update it. But at one point in time, it can only correspond to one value. 1 never corresponds to caret. 3 never corresponds to apple. 1 always corresponds to apple. 2 always corresponds to banana. 3 always corresponds to caret. Now, that's exactly what mappings are inside Solidity. So with mapping, what you can do is you can say a mapping keyword, all right? And then you give it a key data type. So in this case, it could be uint. And then a value, which could be, a string. And you can say a public, my mapping, okay? So in this case, this could be like a mapping of strings. So like 1 would be apple, 2 would be banana, 3 would be caret. The key is always a number. It's a string here, but you can take those off. And this, the value is a string, okay? So in that Solidity, you can make mappings any value. You could say address, and then uint, public balances, and you could have a mapping of balances where it's like, an address 0x0, 1, 2, 3, et cetera, et cetera. I'm just doing abbreviation, and so their balance is, 10. And then 0x0, 4, 5, 6. All right. And their balance is 500 or 400, whatever it is, right? So that's how it works. It's a key value store. The keys can be anything you want to. They can be numbers. They can be blockchain addresses. But you have a key value store. You have a mapping that has a key. All right. And you define the data type address as the data type of the key, and the value, you also define the data type of the value. In this case, it would be an unsigned integer or a number. So going back to our contract here, okay, we have a mapping, which we've created, which is a key value store. The key data type is address, and the value is this token sale, which is this struct right here. All right. And we save that value, make it public, and we save this on the blockchain as token to sale. So basically, it's making it like a database with a lookup of the user's address, and then which in this case it's a token address, and then the value is going to be this struct, which has all the information about the token sale, like the token, the name, the creator, the sold, raised, is open. Okay. So how do we? Now we've created a place to put the token sale with the mapping, but we actually have to write it to the mapping and store it to the blockchain by adding data to the mapping. So how do we do that? So basically we just say token to sale, just the name of the mapping. We give it the key, which is going to be the token, but we want to coerce that to an address. All right. And then we give it the value, which is just sale. Okay. So that's how you save it to the mapping. You give it the mapping, you give it the curly brackets, you give it the key, all right, which is going to be the address of the token. And then you assign the value with the equal sign to the actual value, which is the sale, which we just created right here. And that's going to save it to the blockchain. And we can always look up this information by just passing in the address, and it'll fetch all this stuff back out. Okay. So I know that's a lot, but that's what it is. I'll zoom out a little bit if you want to pause the video, make sure that looks right. All right, we'll go to the top of the file as well. Make sure all this looks right. Okay. And now we'll go run a test for this. Okay, so now inside the test, what we're going to do is put our final test example for creating tokens. We're going to add this here. Okay. And we're going to say it should create the sale. Basically, it should create the token sales so that people can contribute to it. So inside of here, we're going to, of course, load our fixture like this. All right. We want to make sure we get the factory, the token, and the creator. All right. And then what we're going to do first is say const count is going to say await factory total tokens. We want to see how many tokens there are first. All right. We want to make sure the count is right. So we'll say expect count to equal 1. So again, that's coming from here. That's when we did total tokens right here. Okay. So we want to set total tokens equal to 1. Let's just run that test real quick, make sure it passes. All right, it works. So, but let's continue building this test out. We're not finished yet. Let's actually get the items from the sale. So we'll just say const sale equals await factory get token sale equals 0. We're going to get that from here because again, we've got this mapping. We just created token to sale. All right. And how do we actually get the token sale? That's the question. Well, we need a special function for that. So what we're going to do is just below the constructor, we're going to create a new function like this. We're going to say function get token sale. All right. We're going to say uint 256 index. And we're just going to read it from the mapping. Say return token to sale. And then we're going to pass in tokens and then the index. All right, we're also going to make sure that this is public view and then returns token sale. Okay, so you can copy that down, make sure that looks right. That's what we're going to let you pause the video. All right, and we're going to call that function inside this test. So factory await factory token sale 0, passing the index. And then we're going to do, for now, we're just going to log that value out to the console so you can see what it looks like. We'll just say console log sale. Okay. Okay, there you go. So you can see this is what's returned. Okay, it's got these attributes. Here's the actual struct in JavaScript. It's not a struct in JavaScript. It just spits it out as a different data type. But you can see it's got the address, it's got the name of the token, it's got the other address, and then the amount raised 0, and the sales open true. So we can test for all this stuff. We can say expect sale token to equal. We can just check this value right here. And then say await token get address. All right. Let's run that, see if it passes. Yep, it works. And then we can also inspect for all of the other elements just like this. I'll paste this in. You can copy it down if you want to. Let's minimize this. All right. You can just see that entire function. Pause it if you want to. Okay. So we check this token is equal to token address. Sale.creator is equal to the creator.address. Sale.sold is equal to 0 because nothing's happened yet. Raised is 0 because nothing's happened yet. And sale is open true because, again, nothing's happened yet. And by default, it is set to true. So let's run the test and see if it passes. And boom, there it passes. Okay, so we have successfully listed a token for sale. There's a couple of other things that we want to do inside Solidity before we finish this up. I'm going to take out, we need to tell people it's live, but there's one other thing is we need to make sure that that this function has a safeguard around it. So what we want to do is make sure that the fee is correct. Okay. So basically, we don't want someone to call this function without paying us. Okay. Because, the developer went through all this hard work of creating this token sale. They need to be paid for the fees like the application specifies. So we can add a special safeguard in this. So for Solidity, we're going to use a require function. We're going to say require. Okay. And what this does is it makes sure that whatever inside of here is true. Okay. So if whatever's it passed into this is true, then this function is going to continue executing. All right. And if whatever's inside of here is false, then this function is going to stop execution and none of this other stuff is going to run. Okay, the transaction is just going to fail on the blockchain. Okay, so how do we do that? Well, you can put an expression inside of here. You can say 1 + 1 is equal to 2. All right, that would be true, and it would basically, this function would run. All right, but if 1 + 1 = 3, that's going to be false, and that's going to not let this run. So we can put a different expression inside of here. Basically, we want to make sure that the fee is correct. So basically what we do is say message.value is greater than or equal to the fee. Okay, so let's explain that. So fee, again, we set that here. That's the fee that they should be created. So we talked about message sender before. This is who is calling the function. The message.value is any cryptocurrency that's sent in with the transaction. Okay, so again, we did value here at the function metadata here. We did value as the fee. That's inside JavaScript, but inside Solidity, we can also access this because remember, message, anytime you're sending a transaction on the blockchain, that's calling a function, a write function. It's got a message associated with it. We can access that message with a global variable called MSG, and it's got several things we can read off of it. We can read the sender. We can also read the value, which is the amount of cryptocurrency sent in with it. Okay. So we make sure that cryptocurrency amount is greater than or equal to the fee. You could be exactly equal to the fee if you want to, but hey, if somebody sends you a little more as a tip, you don't want to turn that down. Okay. So we can also add a message if this fails. We can basically say factory creator fee not met. All right. And that way, if this fails, you'll have a nice error message that tells you that it didn't work. Okay. All right, so let's save that. Let's run the tests, make sure it still passes. We're not going to write a special test for this just yet. We just want to make sure it still works. You can manually test this. Like you could go in here and then say, 1. And it's going to fail. All right, it just works. You can see the problem here, factory creator fee not met. But we're just going to back that up and then change it back to the fee, and it should work. Boom, there you go. Okay, so the last thing we want to do is let people know that the sale is live. So how can we do this? Well, in Solidity, we can create things called events. So events are basically just a way of finding out that certain things happen inside of on a block. So previously, when we talked about ERC20 tokens, I briefly mentioned this. All ERC20 tokens have events. So you can see this here, event transfer, event approval. So for tokens, you can find out that anytime someone transfers tokens on a blockchain. That's pretty useful. So if you hold tokens in your own wallet and you want to write your own app to make sure that you're not getting hacked, right? If you found out that someone transferred a token out of your wallet, you could get a notification about that with an event. So basically, you can subscribe to events in the blockchain to find out about stuff when it happens in real time. And you can also look at the entire history of something that happened with events by getting an event log, okay, which we'll use that whenever we create the front-end app. So you can create an event inside Solidity like this. You can define one at the top like this, say event created. All right, and you can give it any data that you want to. So we'll say address indexed token. That means we can just look it up by the token later. That's what index means. So that defines the event, but we can actually log the event when we tell people it's live here in the function like this. Say emit created, and then pass in the address token. All right, and that's going to emit the event and tell people it's live on the blockchain. We're not really going to specifically test for that just yet, but we want to just make sure that it works. So we'll rerun the test and make sure that passes. All right, boom, there you go. It passes. Okay, so we have successfully written all the code to create a token, all right, and actually list it for sale on the blockchain. And the developer now is getting a fee anytime someone creates a new token and it spits out these tokens from the contract. Now, what we have left to do is still quite a bit, so we're going to move quickly here. But now we need to let people actually buy the tokens, all right? And then we also need to let the developer, we need to let the tokens successfully fund, so they'll successfully launch, because again, the tokens, they're not open for trading, they're just on the platform like Pump.fun until the sale is finished. And then finally, we're going to finalize the sale and let the developer to withdraw their funds from the platform. Okay, so that's what we'll work on next. Okay, so now what we're going to do is implement buying tokens. So up to this point, we've got a developer who has, created the contract. We've got the creator who can list new coins. Whenever they do this, the developer gets a fee. New coins are created on the blockchain, and they are listed for sale in the factory contract. So now we're going to introduce a new party, the investor, who can contribute Ethereum cryptocurrency or Ether to purchase one of these tokens once they're listed. And of course, they'll receive coins to their wallet, and everything will get finalized after the successful listing. Okay, so let's go ahead and get that started. We're going to create a new function here called buy tokens, or just buy. Okay. And what it's going to do is basically be called buy. It's going to have a couple of arguments. It's going to accept the token they want to buy and the amount. So UNT256 amount. And it's going to be external. So it can be called outside the contract. And it'll also be payable because, the investor is going to be sending an Ether and they're going to receive coins into their wallet. So it has to be payable in order to do that. So inside this function, whenever the user sends in Ethereum cryptocurrency, they're going to get a different token in exchange. So what we're going to do is basically transfer the token to the buyer's wallet. So in order to do this, we're going to use this token smart contract that we imported, and we're going to transfer the tokens to the user's wallet like this. This is step one. We've got to implement a lot of other stuff, but the first core feature of this function simply is just transferring tokens to the buyer's wallet. So we'll say token, all right, and then we'll say underscore token. Basically, that's using this smart contract, but it's specifying which one on the blockchain. So we have to pass in the address. That's the address with the function called right here. And then we're going to use a transfer function. Okay, I'll show you where that comes from. Basically, inside of ERC20 tokens, like we talked about before, they have a transfer function, which lets you move cryptocurrency from one account to another. Basically, you tell it the address you're sending it to and how much. That's the value here. Okay. And we're going to say basically an amount. All right. We're just going to pass in the amount. All right. And then we're also going to tell it who it's going to, which is the buyer. So it's the message.sender. So message.sender. Okay. So that's the core functionality. Basically, when they buy tokens, it's going to transfer this amount of tokens to the user's wallet, and the Ether that gets sent in is going to get stored in the contract. And then whenever the token sale is finalized, it'll get sent so that it can start trading. But that's the core functionality. Let's go ahead and write a test for that. All right. So inside of our test, we've got test for deployment, test for creating. Now what we're going to do is have a test for buying. All right. So we're going to say describe buying. Okay. We're going to do this. We're going to create a fixture for buying tokens because we've got a fixture for deploying the factory. But before we do that, let's go ahead and update this factory to include an investor or a buyer. We'll call it buyer right here. We'll also return this buyer. This is a new blockchain wallet, a signer that we want to track. Okay. So now that's finished. We can go ahead and minimize this. We want to create a new fixture here for buying the tokens. We'll just say token, buy tokens fixture. Okay. So this is what's going to run before each test example when we're buying. So what do we want to do? Well, basically, we're going to go ahead and import the fixture from deploying factory. So instead of calling this in every single test, we can just call it here. So we can get all this behavior inside this fixture. So it's like nested in that way. So we already have access to the factory, the token, the creator, the buyer. Okay. And then we can basically do a buy tokens function call like this. So we're going to set up some variables. All right. We're going to set up an amount of tokens that they're going to buy. Basically, we just want to set up these two function arguments, the token address and the amount. All right. So we'll do this. We'll say const amount equals ethers parse units 18. Basically, what this means is it's going to buy 10,000 tokens. All right. And the cost of these tokens is going to be 1. All right. That'll be easy math. Okay. So we can use these variables here, and we can actually create the buy tokens transaction like this. Okay. We'll say transaction equals await factory connect buyer. All right. And we'll call the buy function. So we'll get the token address. We'll pass that in as the first variable. The amount will be the amount we've calculated here. All right. And then the value will be this cost in ether that we're going to pass in. Okay. We'll wait for the transaction to finish. And then finally with the fixture, we will return just the necessary variables that we're going to need in our tests. So I'm moving a little bit faster to this part. We've seen how to do a lot of this stuff. So I'm going to kind of move a little bit quicker. We've got a lot left to cover. We got to build out the front end. So yeah, that's how we get the buy tokens fixture working. So inside of buying, we're going to write our first test example. Okay. Basically, we're going to make sure that it updates the ETH balance. So basically, we're going to check that the contract received ETH. And we're going to check that buyer received tokens. Okay. So in order to do this, we're going to set some variables here. We're going to duplicate the cost and amount that we have from the test fixture. All right, we're going to put it here. Say amount and cost. And for our first test example, for check the contract for received ether, basically we can just say that it should update the ETH balance. Basically, that the contract received the ETH. Like this. We can load the fixture in this test example, like this. Buy token fixture, we just want to get the factory. Yeah, that's what we set up here. Buy token fixture. Okay. And then we want to get the balance of the factory contract. So do that like this, const balance. And you get the balance with ethers.js. You just say await ethers provider. Get balance. This is how you check an ether balance. So you can check the ether balance of anything. You could check a wallet address. You could check a contract address. We're going to check a contract address here. So we say await factory get address. All right. This is just the smart contract address of the factory itself. All right. And we're going to say expect balance to equal the fee plus cost. All right, so let's run that. All right, so we got a little issue here. I forgot a semicolon. Let's go back here and fix it. All right, run the test again. All right, it works. So they got the fee plus the cost because we add the fee in here because don't forget the fee was already in there when the person listed the token. They're not going to have a fee every time someone buys tokens, but again, there's a listing fee which is already in the contract, okay? And then there's the cost of what the user just contributed, so we have to add that cost plus the initial fee that was in there. That's what the ETH balance is going to be, okay? So now let's make sure that the buyer actually received the tokens. We can pull this down. We can just say it updates the token balances. Okay. And basically, we just want to make sure the buyer actually received tokens into their wallet. Sorry, this text editor is kind of going crazy here. We'll fix that in a minute. So we'll load our fixture. just like we did before. But this time we actually want to get the buyer as well. All right. And we're going to say const balance. So this is, we did the balance here with Ether, but you read an ERC20 token balance differently. So you have this balance of function on the token. You just pass in the address of the owner. It tells you how many tokens they have. So you await balance of, and then you say buyer address. And then we'll say expect balance to equal amount. All right, that's the amount of tokens that they purchased right here, which should be 10,000. Okay. And it looks like I can do this better like this. There we go. That's why my editor was not working properly. All right, so let's go ahead and give it a roll. Okay, so we've got an issue here. Let's go ahead and fix that. Sorry, await token. All right, there you go. So the buyer actually received tokens in their wallet. Okay, so that is the core functionality. And now you're seeing why we write the test and why it's so important, because we're going to add a bunch of other code here. And we want to make sure that that basic code that we just wrote actually continues to work. Okay, so we've got to add a lot of other stuff to make sure that this works. Okay, so what we want to do is basically from this point forward, we need to update, we need to check that the amount is right, check conditions, I'll just put it that way. We need to calculate the price. We make sure, basically check the conditions. We need to update the sale and then make sure fundraising goal isn't met. Because basically if it's met, we don't want people to keep buying tokens. Okay, because that's the whole point of this platform is it's a fundraising goal. You're kickstarting a new token basically. And whenever the goal is met, the tokens are ready for trading. And if they're not met, and if it is met, if it's not met, the sale's still open. But once the goal is met, the sale's closed. Okay, so we got to update all that stuff. All right, and then let's see what else do we have to do. We're also going to alert. We're going to emit an event. Okay, so let's go ahead and do the event emission. That's pretty easy. So we're going to have a new buy event. This will be really handy on the front end later. Okay, so at the top, just below created, we can create a new event called buy, just like this. So event buy, pass in the address of the token and the amount that was purchased. And then we'll emit the event here. Basically, we'll just say, we'll just say this. All right, emit buy. That's the easy part. But now what we want to do is actually work on this other stuff. So there's a lot to do here. So really the first thing that we want to do is make sure that it updates the token sale properly. Okay, so let's actually update the token sale. So basically, you can see our token sale here has some attributes like the amount of tokens sold, the amount that's raised here. So we actually need to update these anytime somebody buys tokens. So we'll first start off with the amount of tokens that are sold. Okay, so what we're going to do is we have to fetch the token off the blockchain from the mapping. So we can do that like this, say token sale, storage sale equals token sale or token to sale underscore token. Okay. So again, we have this mapping where we're saving all the tokens, the token sales. And what we're going to do is basically fetch one from storage. That means off the blockchain, save it to a variable called sale. Again, this is a data type. And we just read from the mapping like this. Okay. So in order to update it, the first thing that we're going to do is basically down here under update the sale, we're going to say sale dot sold. We're going to add the amount. So whenever someone buys tokens, basically we're going to increment that amount. So that's the naive way to do it inside Solidity. Again, we have an increment operator, which we can do like this, plus equals. That's just going to add the amount to this value. That's a shortcut way of doing it. Okay. So we can run a test for that. We can go back to our tests. So it should update the ETH balance. It should update the token balances. It should also update the token sale. Okay. So inside of here, we're going to load our fixture. Just like this. All right. And we're going to load the sale, just like this. You can read from the mapping. Sale equals await factory token to sale, await token get address. All right. And then what we're going to do is we're going to read the amount sold. So expect sale.sold to equal, equal amount. Okay. That's this amount right here. So that means whenever we do this, we're adding the amount. We want to check that this value is actually correct. Let's do this. And it works. It updates the sale. Okay. So that's the first thing. Now, we also want to make sure that it updates the cost. So here's where things get a little bit tricky. All right. So basically, you have to understand how Pump.fun works and how this Launchpad works. So the whole idea is that after a coin's listed and people start buying it, the price actually goes up. That's how Pump.fun works. That's how this platform works. So whenever someone buys, all right, they're the first person to buy, they get the cheapest cost. But as more people buy, okay, it's going to increase the cost over time. So the second person who buys is going to pay more. The third person that buys is going to pay more. The fifth person that buys, fourth, fifth, et cetera, is going to increase the cost. So we actually have to implement some logic inside of Solidity to increase the cost whenever somebody buys tokens. All right. So let's go ahead and do that. Let's just say, okay, here's the storage to sale, update the amount. What we want to do is basically also update the raised amount and update the cost. So the first thing that we want to do is implement a way to get the new cost of the next tokens. So we're going to do that with a special function. All right. Just below this create, say function get costs. Okay. And then it's going to take a uint. It's going to look at how many tokens were sold. Alrighty, we'll pass that in. Say public pure returns uint 256. Okay. So let me show you. I'm just going to add the code for this and I'll explain how it works. So basically, it's going to take the current cost and it's going to create a formula. Okay. That's basically like here, it's going to calculate the new cost. So what it's going to do is take the step. Basically, this is the amount that it's going to increase. It's going to increase by 0.001 ether after every purchase. Okay. And then it's going to multiply that by the amount of tokens sold divided by the increment. Okay. And then you're going to add the floor, which is this initial price. So you get the floor plus the step amount. Okay. Divided by the amount of tokens sold, multiplied by the amount of tokens sold divided by the increment. That's going to help get the new cost after somebody else buys the tokens. So we got a special function for that. Okay. So inside of here, we can use that function to get the new costs. Okay. So basically, we're going to calculate the price of one token based upon total bought. So we'll say uint 56 cost equals get costs. And we'll say sale.sold. All right. So that will give us the cost of the token. And then every time someone buys, this cost is going to increase based on that function that we created. Okay. So that's the cost. And then now we're going to determine the price for the amount. So we'll say uint 256 price. That's going to equal the cost times. All right, this is where the math gets in there, but you can just review this later. If it gets tricky, just slow down and think about it. Amount divided by 10 to the 18 decimal places. Okay. So basically taking the amount divided by 10 total tokens, and you're going to multiply that by the cost. That's going to give you the actual price. Okay. So then what we can do, I'll just add a note here. Make sure enough ETH is sent. We'll do that in a second. But then what we're going to do is basically update sale.raised, and we're going to plus equal the price. And that will give us how much Ether has actually been raised at this point. Okay. So with the factory, and then we'll say const. No, let's do this. Yeah, here. Const cost equals await factory get cost sale.sold, and then we'll say expect. Well, we don't really need that yet, actually. Let's just say sale equals, let's just leave that. And then let's check this. Expect sale.raised to equal the cost. That's this cost that's listed here. All right, let's go ahead and run that test, see if it passes. All right, that passes. And finally, while we're here, let's just go ahead and make a check that says expect sale.isOpen to equal true. We'll just make sure the sale is still open, that we didn't break anything. We don't want it to close. Oops. And it still works. Awesome. So we have updated everything we need to on the sale. Okay. We can also run a test here to make sure that it increases the token costs. All right, we'll just add that in there like this. Basically, it should increase the base costs. So we do our fixture, we load the sale and the cost, and then we expect the cost to be equal to this, because the first one is 0.01, and after somebody buys, the new cost should be 0.002. All right, let's save that. On the test, and boom, it passes. It actually increases the cost. All right, so now we've updated the sale, but we have a couple of other things to do. All right, we want to make sure that whenever this investor is buying the tokens, that they're sending in the right amount. Okay, so we can use a require function for that, require, and we can say basically message.value, which is the amount they're sending in, is greater than or equal to the price. All right. And we can add in an error message if that's not right. Basically, factory received insufficient ETH. So we can look at our tests and make sure that still works. We won't run a new test. Oops. Let's run the test. Make sure it still passes. All right, it still passes. But let's make them buy with less. Basically in our fixture, we could change this to, 1. Let's make it too little. It should fail. Yep, it fails. Okay, you can see our error message, insufficient ETH received. So we're not going to write a specific test for that, but we can kind of manipulate our test to make sure it still works. All right, boom, there you go. So that fixes this. Now, what we also want to do is check on some other conditions. Like we want to make sure that the sale is still open. Like this, requires sale is open true. Because if the sale is closed, then we don't want them to be able to purchase the tokens. We'll talk about how to close the sale later. We want to make sure that the amount is right. So we can say that the amount is greater than or equal to 1 ether. All right, so the factory amount is too low. And then also we want to make sure it's not past the total fundraising goal, which is going to be 10,000 ether. So again, that's going to be the goal for the token sale to actually be finalized. So there you go. I check all those conditions before this function runs. All right. So let's run the test, make sure it still passes. All right, we're good to go. And then finally, we want to make sure that the goal isn't met. So basically, once that goal of the token limit is met, then we want to make sure, or the target, okay, then we want to make sure that nobody can buy tokens anymore. So we're going to save those values at the top of the file. Basically, we'll add some constants. We'll start with the first constant, which is public constant target equals 3 ether. All right. And then we'll also make the token limit, which is going to be 500,000 tokens. So this is the funding target, 3 ether, and the token limit is 500,000 tokens. I know this says ether, but that just makes it so you don't have to write 18 zeros after the decimal place. All right. So we'll save those. And then right here, we'll add the logic to make sure the sale's not, haven't exceeded those conditions. So you can use an if statement inside Solidity. So basically an if statement is just like conditional logic. So like if this condition is met, then you can satisfy these conditions. You'll run this code, but if this condition is not met, then you won't run this code. So like this code. So if true, okay, whatever is inside here evaluates to true, this code block will run. If whatever evaluates inside of here evaluates to false, this code block will not run, okay? So our conditions are that the sale that sold is greater than or equal to the token limit, or, all right, that's how you do or in coding, basically 2 vertical lines, 2 pipes. All right, so this or, all right, the sale that raised is greater than or equal to the target. Okay. What we're going to do is say sale that is open is equal to false. Okay. So basically on that final buy, if any of these conditions are satisfied, if the token limit is now greater or the amount of sale is greater, then we'll go ahead and close the sale, and then nobody else can buy tokens after that. All right, so let's make sure we're on our test, make sure they still work. All right, it still works. Okay, so that's it. We've basically finished the buying tokens. Now let's move on to the final portions of the contract. Okay, so now we're going to move on to the final portions of the contract. We just have 2 functions left, all right? So, we've got an investor who can buy tokens. This could be anybody. It could be multiple different people. But, we just finished up coding some logic that like after a certain goal has met, the price is increasing after every single buy up to a certain threshold. And once that threshold is done, then nobody else can buy tokens anymore. And that is going to basically take us to the point where the coin is now successfully launched and it can be deposited onto a decentralized exchange. Okay. Now, what we're going to do, we're going to code out a deposit function that handles this. So the deposit function is basically going to distribute the funds and all that type of stuff. It's going to sort of officially finalize the sale. Okay. So let's go ahead and minimize this buy function and create a new function here. Okay, we'll call it deposit. All right. And we'll put the logic for that inside of here. It's going to have a token address. Basically, this is deposit, this is a finalized function for a specific token that's on the platform. So what is this going to do? So let's go ahead and add some code comments inside of here so that you'll see how this works. So normally with Pump.fun, how it works is you can buy tokens, you can sell them while it's on the bonding curve, and whenever the goal is officially met, it launches the coin on a DEX, right? So we're going to simplify this just for learning purposes. With our buy tokens, you can't really sell them on the fundraising platform. You could implement that logic if you wanted to for homework, but for the finalizing the deposit, if you were to actually code this out to launch it on a DEX, like, Radium on Solana or Uniswap on Ethereum or Pancake Swap, Sushi Swap, whatever, you would actually have to interface with those contracts directly and create a new liquidity pool and deposit the funds that were raised from this contract plus the tokens so that it can start trading. Okay. Now, for simplicity's sake, what we're going to do essentially is we're going to take the remaining token balance that were not sold in the sale, because the goal is not to sell all the tokens. The goal is just to sell enough tokens to start trading. Okay. So the remaining tokens plus the ETH that was raised, and we're going to basically just give them to the token creator, and then that token creator, could deposit them into a liquidity pool for Uniswap version 3. Now, the airtight strategy would be to programmatically do that with the smart contract, but that's a huge step above what we're doing right here with this tutorial. So if you want to research how to do that, you can look at the Uniswap version 3 documentation and see how to create a liquidity pool. We've got you up to this point. You can definitely do that. But for simplicity, what we're going to do is just send the remaining tokens and the ETH raised to the creator. Okay. Because this is really just for learning purposes. If you want to take the next step, you could actually make that go live on a DEX. So how do we do that? So basically what we're going to do is basically just give this creator the remaining tokens and the funds, and then they could put it onto a DEX, manually. All right. So how do we do that? Well, first we need to get the token sale and the token. So we'll load those up into variables here. All right. So we got the token and the sale. Okay, we get that from the variable here. And then what we're going to do is we're going to make sure the sale is not open. So also, anybody can call this function. That's what I'm trying to say. Because you can also implement this for homework, like on the final buy. Basically like if this threshold was reached, you could call this deposit function and this whole thing would be taken care of. But the beauty of this is anybody can call this deposit function. So like whenever the sale's finished, the creator could call it, some random investor could call it, some random person on the blockchain could call it, the deployer could call it, doesn't matter. Just as long as the sale is not open, then this function can't be called. So we'll add that requirement right here, right? So basically, if the sale is open, false, then this will work, right? But if the sale is not open, if the sale is not open, that means it's finished. We can call this deposit function to reconcile everything. But if the sale is open equals true, then we're not going to do any of this stuff, okay? So what do we do? Well, basically, we're going to transfer the tokens to the creator, just like this, all right? We saw how to transfer tokens previously. So we do token.transfer sale.creator, token balance of address this, all the remaining tokens in the contract, and then any ETH that was transferred to the contract, we're also going to send those to the creator as well. So here's how you transfer ETH inside Solidity. There's a couple different ways to do it. You know, the simple way is to call the transfer function inside Solidity, but for security purposes, it's better to use call. So what you can do is basically take the creator and you can call them with this function right here. So we just make sure that they're a payable address. You do call, and then it's just like sending a message to somebody. You pass in the metadata, the value, you're sending a message to them with the value, and that value is the amount of cryptocurrency you want to send them, which is sale raised. All right, this function returns it returns a success. And if that was successful, then it's going to work, but we revert if it's not successful. All right, so that's going to send it to the creator. So we don't have a test for this yet. Let's just run the test, make sure they pass, make sure we didn't break anything. Okay, it works. Okay, so let's write some tests really quickly. We're going to write, we've done tests for buying. Now we're going to do some tests for depositing. We'll wrap this up quickly so we can get on the front end. Okay. Okay, so what we're going to do is we're going to import the amount and the costs. Okay. So amount and cost, the cost is increased because someone's already bought tokens. And basically we're going to write a test example that says the sale should be closed and the deposit should work. Okay. So inside of this, what we're going to do is we are going to load our fixture first. All right. Then we're going to create a buy transaction for a second buy. Okay. So basically, factory connect buyer. So buy, await, get token address, the amount, value, costs. Okay. We're going to buy the tokens again to reach the target. Okay. We're going to wait for the transaction to finish. Then we're going to fetch the sale like this. All right. And we're going to make sure the sale is not open anymore. Sale is open is going to equal to false. So let's go ahead and run that test. All right, it works. So next what we're going to do is make sure that the we're going to call the deposit function. All right. So factory connect creator deposit token get address. All right. And then we're going to close it and make sure that the buyer received the ether. So say balance equals await token balance of, or excuse me, that the buyer received the remaining tokens. So balance equals await token balance of creator address balance to equal ethers, and then we subtract the amount of tokens that were purchased in the sale from their original million tokens. So it should have gone down by 200,000 tokens. All right. So let's save that. Oops, sorry. All right, it worked. So I'm not going to check for the ether balance because, it's hard to calculate the exact ether balance because, the testing accounts have ether already loaded in them and they're paying gas fees and, ether's coming out of their wallet. So it's really hard to test that the exact ether amount's right. You can write your own test if you want to for homework that just make sure that it's greater than a certain amount. I'll leave that to you as an exercise. Okay, so that is the finalization function that finalizes the sale. Now there's one last function we want to add, and that is for this deployer here, okay, to be the developer to be able to withdraw the fees whenever somebody creates a token. So again, whenever somebody creates a token and they list it, there's a listing fee. Those get stored in the contract, but at any point in the time, the developer should be able to withdraw those to their wallet, okay? So let's implement that right now. Basically, we're going to create a new function inside the smart contract. Okay, let's open the editor here. And we'll go to the factory contract. We'll have a function called withdraw. This is for the developer only. So we're going to add a requirement to the first line of the function. Basically require message.sender is equal to the owner. So only the owner can call this, not somebody else. And we want to basically transfer all the ether that was specified here to the developer themselves. Okay. So again, this is the logic for withdrawing ether, just like we did here. We do the same thing here, except the difference is we're calling the owner instead of the sale.creator here. And we transfer the ETH to the owner's wallet. Okay. So that's it. That's the last function. Let's write a test for it and we'll move on. So I'm going to go ahead and throw in our last test here. You can grab this in the final code solution if you want to, or I'll pause my screen. If you want to pause it right now and copy that down, you can. All right. So basically, we're withdrawing fees. So it should update the ETH balances. We load the fixture. We connect we connect the factory contract with the deployer. We call the withdraw function. We pass in the fee amount. We wait for the transaction to finish, and we make sure that the Ether's balance of the factory is now 0. Okay, that all the fees were taken out of the contract. Again, it's hard to check the deployer's balance because they're paying gas fees. They got initial ETH balance. You could try to calculate it and make sure it's greater than a specific amount if you want to. But for now, we're just going to check that the contract is now empty. So let's save that. Let's run the tests. And it passes. Okay, so now we have successfully finished coding out the entire factory smart contract. Congratulations if you stuck with this far. That's a lot of work. And you have successfully created your first pretty sophisticated smart contract. So now the next thing we need to do is put these contracts on the blockchain, and then we'll start coding out the front end. Okay, so now what we're going to do is take the smart contracts that we've just created, and we're going to actually put them on the blockchain so that we can create the front end application. So up until this point, we've been writing the smart contracts and then writing the tests. Okay, so there's been no actual blockchain involved up until this point. Okay, so every time we run these tests, basically what's happening behind the scenes is hardhat is spinning up a virtual blockchain every time we run these tests. So like if I do this, basically behind the scenes, it's spinning up a new blockchain with these fake accounts that we've talked about right here. Okay, but it's not persistent in any way. You notice we don't have like another blockchain running somewhere. We're not pointed to an actual blockchain. So whenever we start developing out the front end application, we are actually going to run a blockchain on our computer so that we can actually put smart contracts on it. Whenever we create the website, we can point the website to that blockchain and start like actually using it. Okay. So thankfully, Hardhat has us covered here. Hardhat has something called the Hardhat node. Okay. So the Hardhat node is basically just a test blockchain that you can run on your computer that, comes with fake accounts, fake cryptocurrency. You don't have to spend any real money. You can start it, you can stop it, you can tear it down, you can manipulate it, all this type of stuff. And it's a really handy tool. So on the repository, you can see there's this command to start the Hardhat node. So npx hardhat node is how you do it. So what I like to do in my terminal is I like to create, especially in VS Code, create a new tab, which I can do here. If you're using an external terminal, you could probably open multiple tabs. If you're doing a different IDE, you can do this. But now I have two different, sessions. And what I like to do is label these. So I can just do rename. I can say like workbench. All right. And then I can rename this one. And I can call this node. All right. So this is actually the tab that I want to run the Hardhat node in. So I can just pull this up so you can see it better. Say npx hardhat node. That's going to start it. Okay. And whenever it's started, you can see that it's logged a lot of stuff onto the screen. It has shown us that we have 20, I believe, accounts. Yeah, 19, but it starts off with 0. So it's 20. zero base index. So account 1 is account 0, account 1 is 2, etc., etc. It gives us the key pairs. So we've got the address, all right, and it's got the private key. Now, I'll give you a word of warning. If you import these into your wallet with MetaMask, I'll show you later, you definitely don't want to send any real cryptocurrency to this on a mainnet, because everybody's watching this video, and anybody who uses hardhat has seen these account private keys, so they can steal all your money. Okay. So each account in the list also has some fake cryptocurrency inside of it. It's got 10,000 Ether. You know, don't get excited. This is not worth any real money. When I opened up the MetaMask before and it showed like, you know, $36 million, that's why. Because it's using fake cryptocurrency on the hardhat blockchain, the hardhat node. All right. So yeah, there you go. This is all the accounts inside of here. They've each got fake Ether. Now, the first account in the list is going to be the deployer account. So whenever we put these accounts in the blockchain, we're going to run a transaction that creates the contract. This is going to be the deployer's wallet address whenever you're running the deployment scripts, which I'll show you in a second. But that's the first most important part. Also, this is running on port 8545. We'll get to that later when we set up MetaMask. But yeah, you have a local hardhat network running. It's going to be in its own terminal tab. Now I'll go back to my workbench because this is where we're going to run our deployment script. All right. But in order to deploy these contracts, we have to create a new file and tell it how to put these contracts on the blockchain. So we're going to go to this ignition folder. So go to ignition and then go to factory.js. Basically, this is the file we're going to create our deployment script. All right. So what we're going to do inside of here is basically we need to put the contract on the blockchain inside of this function right here. All right. So the first thing we're going to do is basically get the fee for the factory. So let's say const fee equals m.get parameter. And then say fee. And then we'll set that to a constant of fee. We can define that constant here. Again, this fee is going to be 0.01 Ether. All right, so const fee equals Ethers parse units, 0.01. Of course, 18 zeros after that, so there's no decimal places. But basically, we just set up a parameter for this deployment script. All right. And then we're going to define the factory. So const factory equals m.contract. So basically, this is creating a new contract for hardhat to create. It's going to be called factory. And then we just pass in any function arguments that are required from the constructor. Again, the constructor function requires that we pass in a fee. That's why we recorded it here as a parameter. And then say fee. Okay. And then the last thing to do is really easy. We just do return the factory. All right. I mean, you can add semicolons here if you want to. All right. So it's pretty simple. Simple as that. Let's just make sure everything looks right. If you want to pause the video and double check on this, you can. Or you can just copy and paste the file from the final code solution just to make sure it looks right. But this is our deployment script. Basically, this is what creates the contract. This is what defines the contract constructor arguments. We just list the argument here, and then finally we return the contract. Hardhat knows magically how to deploy our contract based upon this information. And finally, we can deploy it like this. You can see the command listed in your GitHub repository. All right. We'll do npx hardhat ignition deploy. And then you're going to do ignition modules factory.js, which is this file right here. You're going to specify the network, -- network localhost. All right. Hit enter. And then boom, there you go. You can see that the contract was successfully deployed. And here is the address of the new contract. And if I go to my node and scroll down, you can see the actual deployment. So contract deployment. Here's the address. Here's who it's from. That's the same developer wallet, CD2266. Let's verify that. Let's see here, 2266. Yep, that's right. And yeah, boom, there we go. Awesome, it worked. Now, one thing to keep in mind is if you've previously deployed the contract, you may want to just add the reset flag. So if you make a code change and you want to deploy again, you might want to do this reset flag. Okay, that's just something to keep in mind. All right, so the last thing we want to do is we're going to need this contract address for the front end later when we create that in the next section. So on our workbench, you can see the factory address right here. So we're going to copy this and we're going to go to our config.json file. So we're going to minimize this. We're going to close all this, and we're going to go to this app directory. We'll get into this in the front end section, but before we do that, I just want to make sure we nail this. Go to the config.json, and this is where we're going to save our address for the smart contract. Just paste that in there. Mine is the exact same. Most of the time when you're deploying contracts in Hardhat, the first contract is going to be the same address every time. So thankfully there's no conflict, but sometimes I've seen this actually change. So always make sure that this address matches what's in your config.json. We'll revisit this file later when we start coding out the front end. But that's it. Exciting stuff. We have created our first smart contract. We've got a blockchain running. You've put it on the blockchain, and now it's time to start coding out the front end app. All right, so now let's start creating our front end application. So for this process, we're going to begin with the end in mind here. And so I've just taken a screenshot of what the completed homepage should look like with a couple of tokens listed, just so that when we start building this out, we can say like, okay, here's where we're going. Here's which element we're going to build next. This isn't actually the working application. It's just a screenshot. We'll just reference this as we're building each element. So in order to get started, what we're going to do is first make sure that you have MetaMask installed. I mentioned that in the dependencies section of this training, but just make sure you've got MetaMask installed in whatever browser that you're using, okay? So you're going to set it up, all right? And we're going to configure this to actually talk to our hardhat node that we just started a minute ago. So again, if you didn't start your hardhat node and you didn't deploy your contracts and you didn't save that to your config.json, just go rewatch the previous section, make sure that you've done that particular thing. So again, I've got my node running here, all right, in its own terminal. I've got the accounts here. I've got, the contract deployed. I've got my separate tab for my workbench here. But let's go ahead and set up our MetaMask to actually talk to this hardhat node. All right, so that's this right here. So what you're going to do is, by default, your MetaMask might be on something like the Ethereum mainnet or whatever blockchain you had it previously pointed to, maybe a test network, maybe a different layer 2. But what you're going to do is need to add a new network, okay? So what you're going to do is create a new one called hardhat, okay? And for the RPC URL, what you're going to do is look at the top of your hardhat node, scroll to the top here. Let's just see. You'll see this localhost port 8545. You can copy that, and you can put that here. All right. And then for the chain ID, what you can do, I'll show you. Go back to your Visual Studio Code or whatever your text editor is. Look at your config.json app. Let's see here. And then copy this number right here. This is your chain ID for hardhat. So basically each blockchain has a unique identifier. Okay, and this is the one for the hardhat node. Now I'm getting this issue that says, hey, the chain ID is already in use. Just ignore that. I've got hardhat already saved, so it's telling me this, but if you don't have hardhat set up, then you're not going to see this error. So currency symbol, I'll say ETH. All right. And then for Block Explorer, you can just leave that blank. And so what you're going to do is save that. All right. I can't save it because I've already done it, but that's how you set it up. And then you're going to want to switch to that hardhat network. Okay. Now, you also need to import the accounts for hardhat. Okay. So your MetaMask is going to give you a default set of accounts. Okay. They're not going to match what comes with hardhat. okay? And maybe you've imported your own accounts into MetaMask, whatever it is, doesn't matter. You can always add new ones manually. So what we're going to do is go back to our hardhat node. And down here, you can see the private keys for the accounts and also the addresses. So, you know, how blockchain wallets work is they have key pairs. So the address is a derivation of the public key. So you have like a public key and a private key. This is not the public key. So the public key and its derivation, the address, which is what you're seeing here, are kind of like the username on a blockchain, all right? And the password is kind of like what the private key is. Now, how crypto wallets work and how blockchain works is if you have the password, that's all that you need. It can actually generate the public key and also derive the address from that information. So if you have the private key, you basically have the keys of the kingdom, and you can use this to build out the account for this particular key pair. So that's how you can import the account into MetaMask. Basically, you copy this, all right? Again, you don't want to store any real cryptocurrency inside here because anybody who's used hardhat or anybody's watched this video could steal your money. And you're basically just going to click on this drop down and do add account or hardware wallet. You're going to do import account, and you're going to make sure the private key is selected here, and you're going to paste in that private key. Okay. So I've already done this. Okay. So it's not going to let me do it. But basically, you can import it and then you can rename the account right here. So you can do account details. All right, you can rename the account. I like to call it hardhat 0. Okay. So basically, like, you can see account 0, account 1. You could name it 1 if you want to, but that's kind of confusing, right? I just stick with the same, naming convention just to know exactly which account it is. It's just less things I have to translate in my head, which is good when you're coding because you always having to think of so many things. So anyways, that's the developer account in hardhat, all right? And what you can do is basically repeat this process for several different accounts. Like I'd advise probably go ahead and do at least 4 of these accounts. I'm not going to do all those on screen right now. I've showed you how to do one. Go ahead and do that for at least 4 accounts because you might want to switch around between different accounts to test this application. So the last thing I'll say is if you ever experience any issues with your accounts, like you're getting mysterious errors whenever you are interacting with the blockchain, it could be because you've reset your hardhat node. Like if you ever start and stop your hardhat node, you're going to want to reset your MetaMask account. So you can see I've already got these old transactions in here. I don't want that anymore. So what I can do is do account details. Actually, hold on. I can do, let's see, where is it? I always forget it. Settings, advanced, and then clear activity tab data. Okay. So as a general rule, whenever you restart your hardhat node, you should see empty transactions here. It's got to do with your nonce being wrong. I'm not going to get into all the details of that right now. But if you have done a previous tutorial and you're just starting this one again, I highly recommend resetting your account. It's not going to clear out any cryptocurrency. It's just going to reset what MetaMask saves in there. Okay. All right. So you've got hardhat set up in your MetaMask. You've got the accounts imported. You've got the connection to the blockchain. You'll know that it works whenever you see your ETH balance here. All right. And that should be 10,000. Again, it's just going to show the US dollar amount. You could, change this to the Ether balance if you wanted to. But yeah, you can see right there. You can see it's almost 10,000 Ether. Okay. All right. So let's move on to the next step. Okay. So now what we're going to do is we are going to start our web server and go ahead and boot that up so that we can start developing out the front end application. So just a quick little bit of theory here if you're a total beginner. We've got a blockchain running right here. That's where our smart contracts are. This is basically going to be the back end of our application. This is where all the blockchain side of things goes. This is where the information that's stored on chain will go. All the tokens, all the investor balances, all that type of stuff, right? That's the back end. That's where the data lives, right? Now, we're about to work on the front end, okay, which is what the user sees. And all the back ends can run on the blockchain, which is this process here. We're going to start a new process on our computer, which is a web server. Basically, it's just a thing that's going to interpret all of the JavaScript files on our computer that make up the website, and it's going to interpret them in real time and spit that out to something that the user can actually see and interact with, okay? So that's really what the web server is. So what we're going to do is we are going to have a new terminal tab here. Again, if you're in your code editor, you can do it that way. If you're using your own, terminal externally, that's totally fine too. I'm going to go ahead and rename this. All right, I'm going to call this server. Okay, and it's pretty easy to start the server. We're just going to do npm, okay, run dev. All right, and you'll see that's going to start things on localhost 3000. All right, so it might automatically open your browser for you, but if it doesn't, you can just copy this, and then you can go to, let's just take one of these tabs, paste it in. And now I can see I've got a website. All right. So this is the starter code. All right. We've got a little bit of stuff done for you. We've already got some background colors here. We've got the logo, and let's see if we have any errors. Okay. So no errors. So how did I just do that? On a Mac, I did Option Command I on Chrome. Basically, that's going to open my developer console. This is going to be something that's really handy that we're actually going to use and leave open. All right, when we're developing this, basically you can debug your JavaScript here. You can read any JavaScript errors on your website. All right, so that's how it's going to work. Okay, so let's go ahead and take a tour of the front-end application. So I've got the server running here. That's looking good. We got their node, our workbench. I'm going to go ahead and minimize this for now just to get it out of the way. So basically, a quick bit of theory. We're going to build all of our front-end application inside of React.js and also Next.js, okay? So basically, what is React.js? Well, it is a framework for writing JavaScript applications. So again, all our backends built in Solidity on the blockchain. React, we're going to build all our front-end in JavaScript, HTML, and CSS. And React is just it's just a framework that lets you create user interfaces for the web, for mobiles, for so many other things, right? But primarily it's used for web applications or just websites that are advanced. And basically what it does is it lets you create all your code inside of reusable components. So you can see, like, here's an example of a component, all right? And like, what is a component? Well, it's something on your website that has, a really defined function to it, or a really defined scope, or really defined, use case, or, like think about it this way, like this is a video component. It just displays a video on a page, or like if you're looking at this website right here, this is a navigation bar. Like this could be a component in and of itself, or this is a hero banner, right? This is a component in and of itself, right? It's just logical groupings of code that you organize into these components, all right? And the nice thing about it is it keeps your code really well organized. You can also do things like reuse components. So if you wanted to render multiple videos on a page, you could just reuse this chunk of code over and over again. Okay, so yeah, that's a great example. Here's a video, here's a video, here's a video, and that's just like nesting different video components inside of there, all right? So a couple of things to note about React is that you'll notice if you look at the code here that we've got JavaScript with this function, but we also have HTML mixed in with the JavaScript, okay? So these little tags here, these are just HTML elements, like a div tag, all right? And this thumbnail is actually a special React component, okay? But you see that you have JavaScript and then HTML mixed in, and then you have some JavaScript inside of here as well. So this is what's called React's JSX syntax. Basically, it's just JavaScript mixed in with HTML. That's how you write the components, okay? The other thing I want to mention is the React state, because we're going to be dealing with this we're going to deal with it a lot. Okay. So let's just take an example of what React state is. Let's see if I can find a good example on the homepage here. They used to have a really good thing about like a to-do list, but let's just imagine that this video component here is a to-do list, right? Like item 1, item 2, item 3. And let's just imagine these hearts are checkboxes, right? Like I've marked the task as done, okay? So if this was a to-do list, how do you know what items are on the to-do list? Well, you need a place in your code to store that, okay? So that's what the React state object is for. So basically, What is state? Well, it's just determining the state of something. It's really hard to define it without using the word itself. But basically, if you think about what is a state of a to-do list? Well, a to-do list that has 3 items on it, that has 1 completed item, that's the state. The state is it has 3 items, 1 thing is done, 2 things are not done. Now, if I check off another one, it has a new state. It has 3 items, and it has 2 items that are completed and 1 that's not completed, okay? So you can think about another thing. What is the state of this individual to-do item? Well, it's completed. All right. The state of this one is it's not completed. All right. The state is the current, current status of something, right? So that's what React state is. We're going to see how to use it. You're going to use all these helpers like use state, things like that, which we'll see with React hooks as we get into this. So the last thing I'll say about React is we're going to use it in conjunction with Next.js, which is just React on steroids. Basically, you're not going to get too many features of Next.js with this particular tutorial, but just know behind the scenes that we're also using Next.js. Okay, so let's kind of get a tour of what's inside of our application. So previously, we've been dealing with these types of folders like the contracts directory, the ignition directory, and also the test directory, okay? And these really come from hardhat, okay? It's also worth mentioning that we have our hardhat config file, okay? This is something you might need to know about in the future. We're just using the default settings, so I'm not really touching on it much in this video. Also the package.json, right? This is where our dependencies go. And also the README, which has all the instructions, of course. But all the code for the front-end application is actually going to be nested into this app folder, at least all the code that you're going to care about, all right? So if I expand this, all these files, the ABIs, the components, all right, all the way down to this test right here, okay? Excuse me, all the way down to this page.js right here, okay? So inside the components, okay, you can see there's some stuff already listed here. We also have this page.js. So this is going to be the main entry point for our React application. All right, we've already got this thing kind of wired up. Basically, this is our default component. This is a React component right here. We're using functional components. So you can just see export default function home. You know, the component is a function inside of JavaScript. All right. And we have this return keyword here. And what it's going to do is return all the code for the component inside of here. So basically, you can see this div class name page. If you're used to writing HTML with the class, well, in React, you have to use class name to avoid naming conflicts. All right. And then we have an H1 inside of here that just says fun.pump. All right. So really, this is just our page placeholder, and then we have an H1 tag here, which is just our site header. All right, so if I go back here on the actual website, I can inspect this component, and I can see the H1 is fun.pump. All right, here's a class page. So you just find that by doing inspect. It'll bring up the HTML here. You can actually see it on the page. That's what's currently on there. That's the code that we're seeing right here. So what we're going to do is, throughout the rest of this here, we're just going to write the rest of our website code to lay everything out. All right, we'll add all of our other components inside of here. You can see we already got placeholders for the other important things that we're going to do, like the header, the list, the token, the trade. All right, that's going to correspond to these other things here, like the header. All right, the list. I can't click it right now because this is a screenshot, but you'll see like a modal pop up where you can list a token. And then, each individual token listed on here. These are all going to be corresponding to individual components. That's what we have here, header, list, token, trade, okay? So, we'll add all the code for these individually as we progress throughout this section, okay? So let's go ahead and perform our first task on the website, which is basically going to be to just add a new component so that you can see how to do that inside of React, okay? And then we'll actually wire it up to the blockchain to see how it works. So the first thing we're going to do is basically display the user's account here, okay? So we'll just add a new component that does this, all right? So let's go ahead and do that. What we're going to do is use this header component here, all right? So if you see this header, basically we've already got a placeholder for this. All right. It's already imported into our file at the top. So if you ever add a new component in the future, let's say you wanted to add a footer component. All right. You've actually got to import it. Okay. Okay. And you have to create a new one called footer here, fill it out, and then basically import it like that. But we've already imported everything for you just to get things moving quickly. All right. So we have a placeholder for it here. We've got to import it into page.js. Now, how do we show it on the page? Well, what we're going to do, all right, is we are going to, let's just see here. We're going to, just below this, all right, we're going to do this, and we're going to say header. So we basically just type the name of the component like this, okay? And now you can see that's how you create a React component. Basically, you write it like HTML with the opening tag and closing tag, and then you use the component name like this. Now that's going to render it on the page if it has everything that it needs. But one thing I'll show you is you don't have to have a closing tag on all your components. You can basically just have a single tag with a closing thing right there if you don't want to put anything in between it. Like if you had a component that needed stuff inside of here, like, hi, this is my content with the opening and closing tag, you could do that, all right? But if you don't have any content in between, you just do it like this, okay? Now, what you're going to notice is our header actually requires some information, okay? It's going to require the account, all right, and set account. So these are like arguments inside the function, so we can pass these in. And I'll show you like this. You pass in your arguments to the component like this, account. And then that's what's going to be correspond to this account variable here. And then also set account is going to correspond to this right here. Okay. So for now, we're just going to keep this empty. And for this, we're going to set an account like this. Let's just copy an account from hardhat. Let's go to our node and let's just copy the first account in the list. All right. And let's paste it in. Okay. And so now let's just do a paragraph tag, hello world, just to see if we can get some text on the page. All right. So let's go to our website here. All right. So we've got an issue. Let's just fix that really quickly. All right. So I see what it is for now. It doesn't like that I've kept this empty. So let's just put an empty string inside of there for now. All right. We'll come back and fill that out in a second. But now if I go here and refresh the page, I can see this hello world came up right here. Okay. So now I've actually got something on the page. Now this isn't actually what we want to see. Of course, we want to have the logo over here and the address over here. Let's go ahead and fix that. So we are going to take this H1. All right. We're going to cut it out of this file and we're going to move it to the header section. Okay. So now inside of here, we're going to do this. All right. And do H1 style this way, fun.pump. Okay, let's save that. And then let's make this a button. Oops, sorry. All right. Okay, so now we see fun.pump over here, and we see this. All right. Let's make some other changes. Instead of H1, let's make this a paragraph tag. Okay. And then let's change this from this. Let's take the style off. Let's say class name equals brand. All right. Okay, now this is starting to look like our mockup. All right. And then for this button, what we're going to do is add a class name equals btn-fancy. All right. And then now this looks a lot more like our mockup. We can see this fun.pump and then hello world. Now, really quickly, you see I'm just adding CSS class names. Again, with React, you can't do class. You have to do class names if you've done HTML before but haven't used React. This is to avoid naming conflicts, okay? And I'm adding these classes, which is going to pick up styles from the style sheet. So if you're a new developer, basically, you write your HTML to lay the code out on the page with these HTML tags, okay? That's, again, we're doing this with React, so it's in JSX. It's mixed in with JavaScript. But the actual formatting of the content on the page comes from CSS, okay? So if you look at, let's see, global.css, we've already pre-written all the CSS for you for this entire thing, okay? I don't want to, make this a course on CSS. There's lots of other great resources about that. So we went ahead and wrote the CSS for you. So all we'll do is apply the class names to our HTML component, our HTML elements, and it'll pick up the styling for you, okay? So that's why we're seeing this already look nice, all right? It's got this cool animation. So let's change this hello world to the actual account. So what we can do is take this account here, it's getting passed in, and we can use that as a variable. So if you're gonna read a variable or evaluate JavaScript at all inside of React, inside of an HTML element, you're gonna use these curly braces, all right? So I could say like 1 + 1 equals 1 + 1, click save, I should see 2. Yep, I see 2. So you can do any type of thing you can do in JavaScript inside of here. You can also just give it a variable name, which is this variable right here, account. All right, click save, go back here, and now I can see the entire account on there, all right? Now, a quick note is if I took these off and just said account, it's not gonna actually show me the account. It's just gonna show me the word account. That's because this is just bare text, but if I actually want to read the account variable, I have to put it inside of curly braces like this because that's what actually evaluates the JavaScript. Now, in order to truncate the account to make it look like this, where we have the ... in the middle, we're going to use the slice function inside of JavaScript, and we're going to truncate it this way, all right? So I'm going to replace this with this, all right? So you can copy that down if you want to. But basically, this is saying take the account, take out these first characters, all right? 0 through 6, it's 0-based index. 0 is the first one, 6 is the 7th one. And we're going to add an ellipse right here. And then we're going to take these last characters from the account, okay? So save that. And then now, now this looks like our mockup. It looks the exact same. Great. Okay, so the next thing we need to do is actually connect this to the blockchain and read the real user's account from MetaMask. So right now, what we've done is we have just copied and pasted the account right here. We actually want to read this value dynamically from the user's MetaMask, okay? So what we're going to do is create a function inside of our page here called load blockchain data. And this is going to be something that's very useful for the rest of our application. So we'll say async function load blockchain data. All right. And then we'll put it like this. Make sure it's right. Yep. And so what we need to do is basically connect to MetaMask and then pull the account out. Okay, so up to this point, all we've done is created a website that just shows some information on the page. The website right now is not actually talking to the blockchain in any way. So how do we do that? Well, we already have MetaMask installed. So this is the tool that turns our web browser into a blockchain browser, okay? But what we need to do is actually turn our website into a blockchain website. And that's actually what ethers.js does. Okay, so you can already see ethers imported into our project here. It's in the package.json. We've imported it into our page.js. So what we need to do is actually tell ethers to connect to MetaMask. And basically that's going to connect to our web browser, which is going to connect to the blockchain. And then our website will be a blockchain website. Now, how do you connect to MetaMask with ethers? Well, they show you in your getting started documentation here. Okay, so basically you need to import ethers into your project. We've already done that. And now you need to use this thing called browser provider, okay, which we can already see is imported. Well, we don't actually have to import it. You can just read it off of ethers directly. They do it a little bit differently. I'll just show you that in a second. But basically, what is a provider in ethers.js? Well, basically a provider is something that provides the connection to the blockchain for you. In this case, MetaMask is going to provide the blockchain connection. So we're using a browser provider. MetaMask runs in our browser. It is a browser provider. And they show you how to initialize this connection right here in their docs. So basically, you just say, you can do it this way, or you can use this ethers browser provider, and then you inject this thing called window.ethereum, okay? So if I go here to my developer console, I can do window.ethereum, and you can see, let's see, when I spelled it wrong, window.ethereum, and you can see that an object pops in here. That's because MetaMask attaches something called ethereum to your window object in JavaScript. So window is just a global variable in JavaScript. It just means the window of your web browser here. There's all different types of properties on it, but MetaMask just attaches this thing called window.ethereum that your application can read and create a connection to the blockchain. So that's what we're going to use. Basically, we're going to create a new ethers browser provider with window.ethereum. And then basically that's going to connect MetaMask to ethers, and our website will be able to talk to the blockchain. So we're going to do that here inside this load blockchain data function that we just created. All right. So we're going to do it like this. We're going to say const provider equals new ethers.browser provider and say window.ethereum. That's exactly what's in the documentation right there. It's basically just copy and paste. All right, you can see it right there. There you go. All right, now we need to actually save this provider because we're going to use it later in the application. So we just saved it to a local variable here, but we're actually going to need to read it like other places in this file. And so if I wanted to read provider here, I can't access the value of this variable because it's just a local variable here. So we're going to use the React state for that. And specifically, we're going to use hooks. So state, again, is just something that lets you save data into your components, kind of like a database. Again, we talked about the to-do list example later. How do you store which to-do items are on there? Well, you put them in the state. Well, any other data, like the provider, you can also put in the state. Or the account of the user here, we can also put in the state, which I'll show you in a second. So you use React hooks for this. All right, so let me show you how that works. I say const, I do an array here. I say provider, and then set provider, okay, equals use state, and then null. All right, so what is this? Well, basically, use state is the hook. All right, it's a function that's going to say, hey, create a new placeholder in this component state for some information. All right. And this null right here is just the default value. So if I did this, I could say foobar, and that would be the default state of the provider. So if I read the provider value the first time, it would be foobar, okay? Or it could be 1, it doesn't matter, but I'm just saying null because I want it to be empty whenever we initialize this component, all right? And what this function is going to do is it's going to return an array with 2 values. This first value, all right, which we're just saving to a variable here, is going to be the actual provider itself. So right now, this is going to be null because the default value is this. It's also going to give us a function to update this value. That's what this function right here is, set provider. So basically what I can do is I can say set provider, and then pass in provider here. That's going to be this provider. All right. And then now it's going to save it to this state whenever we call this function. Okay. And now I'll be able to read provider from this variable. I know it's the same name as this, but I'll be able to read it from this variable at other places in the application because I couldn't do it previously because this variable is not accessible outside this function. So, yeah, that's how it works. Now, we are connecting to MetaMask, but you can see that we're not actually like let's do this console log provider. Let's try to log the provider and see if it comes out. Let's go back to our website. Let's refresh. Okay, you don't actually see the provider logged to the console. Well, that's because we've just defined this function. We're not actually calling it. So how do you call it whenever this component loads? Well, we use a function in React called useEffect. All right, so useEffect. All right, so basically what this is going to do is it's going to run whenever the component loads, and then we can call whatever function that we want to do in here. So we can just say load blockchain data. All right, save that. And now if we go back to our page here, we can see that the provider is actually getting logged to the page over and over and over again. All right. So let's just refresh that. And it's giving us an infinite loop, so we'll fix that. So you can fix that here after this curly brace, just do a comma and put an empty array. Okay. This is going to give us the conditions for change later. We'll add some things to this, but for now, just add the empty array and then go back to your page. Just make sure it looks exactly like this. You can you can pause the video if you want to. And then boom, there you go. You can see the browser provider is logged to the console. All right. You could even prepend this with provider just to see as a sanity check. Refresh the page. You see the word providers here, and then here's the provider. Okay. So now this is loading. Okay. All right. So the next thing that we want to do is actually fetch the user's account from MetaMask. Okay. So how do we do that? Well, you can do it with the documentation from Ethers. I'm not going to reference it just yet. But let's go ahead and show you. I'll just put the code right here. So you just do await window.ethereum. Again, the window.ethereum is what we use right here. And we can just request the accounts directly from MetaMask like this. Say request method ETH request accounts. All right, we can say that to a variable. We can say const accounts. That's going to give us an array, which we can log here. All right, let's kill this other console log. And actually, before we do that, let's just do accounts 0. This is going to be an array. So we can just get the first element from the array with this syntax. Okay. And let's go and refresh the page and see, boom, there you go. So 226, 226. So we're not actually displaying it on the page. This is just happens to be, what's coming in from MetaMask. I could change this to foobar for now, so you can see that this doesn't match, right? Foobar. And then this is the account. So what we want to do is actually show this value up here. All right. So let's see how we're going to do that. Well, just like we did set provider and provider with the state here, we're going to do the same thing with the account. All right. So what we're going to do is just say const account and then set account, use state null. And then we're going to just say set account here. And we'll say accounts 0. We'll remove that console log. All right. And then now we have access to the actual account here, and we can just pass that in. All right. Okay, so now what you're going to see is a problem. It's going to say, hey, I can't read this because it doesn't exist. So we need to add some conditional logic to it. Basically, the first time you load it, it's not going to have your account. And inside this header.js file, it's trying to call slice on an array. You could fix that a couple ways, or on a string. We could just do this. Let's just do this for now. Do an empty string. And then, boom. There you go. We can see that that works. But let's actually make this better. Okay, so that's the actual account it's reading. It's passing in to here, and then it's effectively reading it right here from here. But you have a problem, okay? You see this flash of content on the page. We don't really want that. That doesn't look professional. So we're going to add some conditional logic to this. Let's take this off and, make it null again. All right, it's going to break the page because it won't load it properly the first time. But let's add some conditional logic inside of here. Basically, we're going to say, you can add conditional logic in React like this. You use a ternary expression. So normally, let's just talk about ternaries. Normally, in JavaScript, you say if, condition, then, do something, return true, else, return false. I know it's kind of elementary, but you get the idea. But in JavaScript, you can also write this with a ternary, which is a single line, which basically says like, condition, and you can do a question mark. And then if that's true, return true, else false. Okay. So that's how you write a ternary. It's basically taking this if-else statement and writing it on a single line. Now in React, you're going to see this broken up onto multiple lines like all the time, right? That just kind of happens. We'll see that as we go through. But that's how you do if-else most of the time inside of templates or components. So basically what we can say is if the account exists, question mark, then we want to return some specific content on the page, okay? And if it doesn't, we want to return some different content on the page. So if the account exists, then we're going to return exactly what we have, all right? We can do this, all right? And if not, we can just write the word connect. All right. So you can see like if the account exists, show this. If the account doesn't exist, show this. All right. So let's save that, go back to our page. And you can see that connect flashes and then the account shows up. So that doesn't break our page. That's moving in the direction that we want to go. But finally, what we want to do is instead of just fetching the user's account as soon as the page loads, we want to ask for permission for their account. So we want to show this connect button and then actually click the connect button and basically load the account that way. So how are we going to do that? Well, we can basically, let's just stop passing in the account for a second. All right. Let's just make this null. And then now we see this connect button here. What we want to do is click this connect button and then run this code right here instead of running it automatically. All right. So how do we do that? Well, what we can do is we can write an on-click handler. All right. And basically, what this is going to do is say, hey, whenever you click this button, run what's ever inside of here. And so we can write a special function that's going to get run whenever that button's clicked. We can call it connect handler. All right. And inside of here, well, you can run this function. So for now, we're going to do just console.log clicked. All right. So if we go back to our page, we see this connect button. We click on connect and we can see that clicked is logged to the console. All right. It's not actually fetching the account from MetaMask, but we can make that happen. Basically, we can go here. We can take out this, and then we can put it here instead. So now, whenever we run this, it's actually going to run the code, and it's going to set this. Now, let's make this a little bit better. Instead of just doing that, let's add this account equals ethers get address. It's going to format the address properly for us. and we can pass in the account there. All right, it's going to set account because we're passing this in, and then we'll have the account passed down to us. So we don't have to move this down to this component, okay? We're going to keep it here so we can use the account in other places. But what we do need to do is actually update this set account to this function that we've defined here. So as long as we pass this function down, we should be good to go. All right, let's save that. Go back to our page. And now if we click connect, all right, it's not quite doing what we want to do. Let's just see here. It's because I still have account set as null here. Sorry about that, everybody. So basically, we're managing the state up here in the page. So account needs to be here and here, and then set account needs to be here and here. And then we reference those inside of here. All right, we're going to set the account actually here. After we click this button, it's going to call this set account function, which is going to save it up here and then pass it back down into the component and re-render it with the correct data. So let's try that. All right, so connect, and then boom, there you go. We have actually created a way for the user to connect to the blockchain when they want to, rather than it happening automatically. So boom, there we go. We've created our first React component. We've actually turned our website into a blockchain website. It can read real blockchain data from the MetaMask account, and it can show the user's account here on the screen. So that's a great first task. Okay, so now that we have actually, wired our application up to the blockchain, we've created this header. I'm gonna go ahead and close this down because I'm pretty sure this is finished. Now what we want to do is actually talk to these smart contracts on the blockchain, okay? So let's talk about how to do that in Ethers.js. So this is the documentation for Ethers.js whenever you're interacting with smart contracts, okay? So basically, you can see what our goal here is to create a JavaScript version of the Ethers contract so that we can basically call its functions. If we want to read information from the contract, like, hey, which tokens can I buy? Or we want to write information to the blockchain, actually create transactions by calling write functions. Like when we buy a token, we can also do that on this JavaScript version of the smart contract. So we'll come back and revisit this in a second. But basically our goal here is to take this solidity contract from the factory that we coded out previously and basically make a JavaScript version of this so that we can call its functions. And our first sort of task is we just want to get like the fee. We want to just make sure we can read some data from the blockchain. This fee is going to get set in the constructor function, and we'll show that out on the page, okay? So in order to do this, we're going to need to create our JavaScript version of an Ethers contract like this. Basically, we create a new Ethers contract, and it's going to need a few pieces of information. The address of the contract, we already have that. The ABI, which I'll talk about in a second, and then the signer or the provider, okay? So we have the provider already. That's our browser provider that we loaded with MetaMask. But let's go ahead and just talk about each of these pieces of information. Let's talk about the address. Where is that? Well, let's go ahead and get all these things individually, okay? So if you look at the config.json, we updated this at the end of the last section, when we deployed the contracts. So this config.json, what it does is the configuration file for our front-end application, and it tells you the address of the factory contract, okay? Now, it does it per network, so you could have this contract on multiple networks. You could have it on the main net, you could have it on a test net, you could have it on a different blockchain, and each blockchain uses a unique network identifier or a network ID. So for hardhat, this is the network ID. So we save it underneath the hardhat network ID. So basically, if we want to look up any contract address for our project, you could extend this. You basically say, all right, for the hardhat network, this ID, tell me the factory contract address, and that's what this is. So that's the first piece of information that we need. So you can see the config.json is already loaded into our project here. All right. So we can go ahead inside of our load blockchain data function. We can fetch that out. We can just say config, It's just a JavaScript object. And then we can pass in the network ID and then also the information that we want. Now, we don't, well, let's just do it this way. All right, let's go ahead and just copy this. Okay, config, pass in the network ID, and then say factory address. And then let's console log this. Let's see if it'll work. We may need to change that to an actual number. Let's just see here. All right, boom, there you go. There is the address from our config.json. We're reading it. That's how we get it. So config, pass in the network ID, and then that's the address, AA3. And AA3 is what's logged to the console. So this is our first piece of information that we need. All right. Now, what we really want to do is actually get the network ID dynamically. So if we switch to a different network, we want to show that on the page. Okay. So you can actually get the network from MetaMask like this. You can say const network equals await provider dot get network. Okay. And then we can console log that. Okay. Let's just see here. I think I misspelled that. Misspelled await. Okay, you can see the chain ID is listed here. So it's an object, but it contains a chain ID. So what we can do is just say network.chain ID. Save that. And then, boom, there you go. It's got the number right there. So now I can take this network.chain ID, and then instead of console logging it, I can actually replace this with the network.chain ID, and it should show me the address on the page. Yeah, boom, there we go. So now we're actually fetching the chain ID of the network directly from MetaMask rather than hard coding it. That makes our app a lot better. So we can just say address. All right, here's the address. So again, going back to ethers, what we're trying to do here is create a JavaScript version of the contract. We need the contract's address. That's the first piece of information. We've successfully fetched that. Now we need the ABI. So what is the ABI? Well, that just stands for the abstract binary interface. Basically, it's a JSON file that describes what the contract looks like. Basically, what functions does it have that are externally available? What are the variables? All that type of stuff. So it's not the full contract code, it's just the interface. So if you go back to your hardhat side of things and you go to the artifacts, contracts, and you see factory.sol and click on factory.json, you can actually see the ABI inside of here. So it's this big JavaScript object. You can see like it's got this name of create, that's a function name, deposit, that's a function name, fee, that's a variable that we can read. Okay. So what you're going to do is minimize this and copy all these, everything inside this array. And you're going to make sure that's in your front end application. So if you go to app, ABIs, go to factory.json, it's already in there, but you can just replace your most updated version of this just to make sure it looks right. Okay. So that's what this ABI is right here. And we need this so that ethers can create a JavaScript version of it. So we get the address, now let's fetch the ABI. So you can see we can import the ABI right here. Factory, ABI is factory.json, that's just the same file. It's already wired up for us. Okay. And then now we can just do console, a log, factory, ABI, and just say factory. All right. And now you can see that that is also logged to the page. Okay, there's our factory ABI. So now we have all the essential ingredients that we need. We have the address, we have the ABI, and we already have the provider, which is right here. So we have address, ABI, and provider. And now we have everything we need to create the actual factory contract. So what we can do is say const factory equals new ethers, ethers, capital C contract, and then put in all of our ingredients. So here's the address. Here's the ABI. And then here is the provider. All right. And we can just console log that. All right, let's go back here. And we can see here it is. All right, now that doesn't look like much. It's just in our console. But let's see if we can actually read some real data from the blockchain with our JavaScript. All right, let's see if we can actually cook with some gas here and fetch some information. So again, the contract was deployed with a fee. So if we go to contracts factory.sol, you can see we already set a constructor function with a fee, and we can read that fee with a variable. So let's go ahead and see if we can pull that fee and log it to console. So how do you read a function whenever it's, wired up in JavaScript? Well, it's pretty easy. It's a read function. So it's simple. Say const fee equals await factory dot fee, just like we did in the tests. And then console.log, say fee. All right. And then boom, there you go. There's the fee. Of course, it's got 18 decimal places after it, but it works. Okay. So boom, there we go. We are cooking with gas. We have pulled our contract in. We can read information from it. We got the user's MetaMask account. Now we've got a lot of important stuff set up, and we can move a lot quicker for the other parts of this application. Okay. So finally, what we're going to do here is save this fee so we can use it later. We're going to create a place in the state for it, and also the factory contract. So we'll say const factory set factory, const fee set fee, use state null, and then we'll set this default value as 0. So we'll save the factory just like this. We'll just say set factory because we're going to need to use it later. And for the fee, we'll set the fee right here. All right, we'll go back to our page, make sure nothing broke, and boom, that completes our first major step. Okay, so now what we're going to do is actually list some tokens so that we can start seeing some results on the page here. So what we're going to do is actually go ahead and create a token through the user interface so that we can display some on the screen here. So again, going back to our smart contract, what we want to do is actually call this create function. So we're going to create a user interface to do that. And then we're going to basically call this function inside of there, and then it'll show up on the page. Okay. So what we're going to do is click a button here, have the form pop up, we'll list the token, and it will show up after we finish that next section. So let's go ahead and get started. What we're going to do is basically use this component inside of here. Let's close down this blockchain stuff just to organize things. We're going to use this list component right here. All right. So let's go ahead and just add, this is got a couple steps. Let me just think about what we want to do here. Let's go ahead and do this. So let's add the button to the page to make that pop-up appear. All right. So we're going to add some content to the page. We'll add a main section here. All right. We'll put some content inside of here. We'll have a div. It says class name equals create. Oops. Create. All right. And basically we're gonna have a button that says, let's give it a class name. Button. Fancy. And let's say start a new token. We can put that in these quotation marks here just to not confuse React too much. All right, so let's see what that looks like. All right, so start a new token. All right. Now what we want to do is actually click this and make it do something. We want to make a pop-up a modal. All right. So let's add some logic to do that. We're going to have an on-click handler. Okay. And we'll get this a function. We'll call it toggle create. And we'll create a function for that at the top of our file. We'll do before load blockchain data. We'll just say function toggle create. And for now, we'll say console log create. All right, let's go here. And then now, see, I click that, create is logged to the console. So what we want to do is actually make this, we want to make this pop up a new component. All right. So I'll show you how that works. First, what we're going to do is basically render this list component on the page. All right. So I'll add the list component here. Say list. It's already imported. All right. It needs some arguments. It needs toggle create fee provider factory, server toggle create. What we'll do for now is just do an empty function like this. We'll say token is equal to token, and then provider is equal to provider, and then fee factory is equal to the factory. All right, so let's see if that shows anything on page. All right, so it doesn't like that very much. Token is not defined. Sorry, I did the wrong thing. This should not be that. It needs to be fee provider factory. My fault, everybody. All right, so now we can see a black screen just comes up. That's just the overlay. So if I go in here into list and I say, paragraph, create token, now we should see create token is on the page. Now we'll lay out all the content for this in a second, but now you can see by default, it just shows up on the page. But what we want to do is have that button behind here, which you can see. We want to click that button to make this pop up. All right. So that's what this on-click handler is going to do. So how do we do that? Well, we can create a state for this. So again, React state is useful for storing data. It's also useful for component state. Like, hey, is this modal launched? Is it not launched? Is this button clicked? Is it not clicked? Okay. So basically we can create a new thing like this. Show create, set show create. And inside of toggle create, we could say show create. Well, basically we could just say set show create and then true. And then here inside of this list, what we can do is add some conditional logic that basically just says show create. Oh, sorry, show create. Sorry. And say and then put this here. All right, let's see if that works. All right, there we go. When we click it, this pops up now. Okay. So let me explain this. Basically, this is an AND operator, which just requires both things to be true. So basically if show creates true, then this by default is true, and it's going to return this onto the page. It's just kind of a weird React way of doing some shorthand conditional logic. I don't want this to be a full-on React course, so you can go look that up more if you want to. Basically, that's how I'm going to handle it in this situation. All right. So boom, there you go. It launches it. Now, we also want a way to close it. Okay. So what we can do is pass in this toggle create function here that we created a second ago. All right. It should still work. All right. And we want to update this logic in here. All right. To where if it says show create question mark, then set show create true. Sorry, false. And then set show create true. So basically if it is already, we're toggling it. So if it's already on, we want to turn it off. And if it's not on, then we want to turn it on. Okay, let's go do that. Let's make sure it still works. It still works. But now inside of here, we want a button to close it. So let's go ahead and do that. So inside of this list component, what we're going to do is have a button. Okay. We'll say cancel. And we'll give it a class name. Button. Fancy. And we'll basically add our on-click handler for toggle create. Okay, just like that. Now let's start it, click cancel, and it goes away. There we go. Awesome. So our modal is working. Now it doesn't do anything. There's no form here to create a token, but I want to get this UI wired up so that it works, and we don't have to worry about that later. So the final thing I want to do before we wire that up is add some safeguards in our application here. So basically, before we let people create a token, we want to make sure that some conditions are met. They need their MetaMask account connected, and the factory contract needs to be loaded. Okay, so basically what we're going to do is say on click, we want to make sure that the factory is there. It needs the factory. And it needs the account, and it will return the toggle create function if the factory is present and the account is present. And if any of those conditions are not met, like if the factory is not there, so bang, the opposite of factory, we want to add something. Okay. And if the account is not there, we want to add something. And then if both those things are met, then we want to do something. Okay. So if both those conditions are met, we'll let them start the new token, just like we have here. Okay. But if these other things are a problem, we can say like, contract not deployed. So that's pretty useful. Like if you load your application, but your contract's not there, it'll tell you. And if the account's not there, it will say, please connect. All right. So let's just see if they broke anything. Yeah, I broke something. Let's just see what it is. All right, so let's fix it. So I actually like really having these errors on the screen because, it's a lot for me to sit here and like code and think about what I'm doing and present and, make this work in real time. A lot of content creators will edit this stuff out. I like to leave it because, you're seeing what real software development looks like. Basically, I just added this this colon there, and that shouldn't be there. I'll see if that fixed it. No, it's still broken. Let's just fix it real quick. So we'll say bang factory. If that doesn't exist, we're going to do this. Okay, this, and then or the account is not connected. Or this, or this. Let's just see. Okay, that's what it was, right? All right. So that should fix it. Yeah, boom. There we go. So you can see the flash, the contract's not deployed, but it works now. All right. So you can see also, please connect. My MetaMask is not connected, so it's working properly. But if I click connect, now we can start a token. So all this conditional logic is working. So it flashes, contract not deployed. Okay, now it's detected the contract. And then now it says, please connect. Click connect. Now we can start a new token. All right, so that's all the UI that we need to do here. Okay, so now let's go into the list component and let's actually create a way to create new tokens in the blockchain. So we're going to go ahead and take out this placeholder paragraph tag. We're going to add some HTML. We'll add an H2 tag here for our title, and we'll say list new token. All right. We're going to give us a div. Okay, we'll make this a class name. Class name equals list description. And we're going to say, give us a paragraph tag here. It's a fee, and we're going to actually show the fee on the page. So we can do it like this. Fee comes in from here. So we can say fee, ethers, format units, and do fee, and say 18. ETH, that'll format it the zeros, extra zeros off. Okay. And then what we're going to do is create an HTML form to actually list the token. So I'll give it an input. Say type equals text. Name equals name. Placeholder equals name. Copy that again. All right, this one will be ticker. That's for the coin symbol. And then finally, let's be a submit button. And then we don't need placeholders or names. We'll say value equals list. Okay. And then there we go. Let's see what that looks like. All right, so I got a little issue here. Let's just fix that. Shouldn't be in here. Should be outside here. All right, so please connect. Let's connect. Start a new token, and boom, there you go. We can see our listing form for the fee. So it looks like it's not properly loading the fee in there. So let's just see why. Let's make sure our fee is actually logging properly. Oh, I accidentally deleted the set. So set fee. Let's try that again. Okay, there we go. Now we can see the fee is 0.01 ETH for listing the token. Okay. So the whole idea here is that we're going to say, Pepe coin, and say Pepe, or whatever coin you want to. I'm just going to use that for now. We want to click this list button, and we want it to actually list on the blockchain. Now, it's not doing that yet. We actually have to make it talk to the blockchain. So how do we do that? Well, we're going to create a special function inside of our list component that talks to the blockchain. So basically, whenever the form submits, we will give it an action and tell it what function to call whenever that happens. So we'll say list handler. And we'll create a new function here called list handler. And pass on the form data. All right. And so for now, what we're going to do is say console log submitted. Okay. So let's do that. Connect, create a token, Pepe coin, Pepe, and see list. And you can see submitted is logged to console. So inside of here, what we want to do is basically get all the information from the form. So let's do that first. Let's say const name equals form.get name. And then let's get the ticker. Const ticker equals form.get ticker. And we can just pass those in, name, ticker. All right. And then say Pepe coin, Pepe. And we can see Pepe coin and Pepe are a lot of the console. We are fetching those from the form, which is passed in here. We can use these get functions just to get the values of name and ticker. Okay. So how do we actually talk to the blockchain? Well, let's look at what we did in the tests. We're going to do the exact same way with ethers.js. So if we look here, let's just look at the fixture for creating a token. Basically, we just did factory connect, and then you get the buyer, okay? And then you click the buy function. Well, that's for buying, so let's look for listing. Factory connect creator, create, and then you pass in the name, the ticker, and then you do the value, okay? And then you do wait transaction wait. So of course you also need to get the signer in order to do that. So we get the signer, and then we call the contract just like we did in the test, but we're going to do it here in JavaScript. All right. So to get the signer, we can get a signer directly from MetaMask like this. This will be the MetaMask wallet that's connected to the website. Say const signer equals await provider get signer. All right. And then to do the transaction, we can say const transaction equals await factory connect, and then pass in this signer here. Oops. And then say create, call the create function, pass in the name, ticker, and then of course we need to do the fee as the value. And then we simply do await transaction wait. All right. So let's see if it works. Refresh, connect, start new token, Pepe coin, Pepe, click list, and it's not working. So I misspelled create. Yeah, that's great time, everybody. Create. Let's try again. All right. Connect, start new token, Pepe coin, Pepe, list. All right, here we go. We see MetaMask popping up. It is giving us our transaction fee that we have to pay to the blockchain, and then it's adding on our 0.01 Ether fee as the listing fee. So the total fees are here. So let's click confirm with MetaMask and see if we get any errors. All right, so it's submitted. Let's see if it comes up on MetaMask. Boom, the create function finished. Awesome. We have just created a coin on the blockchain with our application. That's a huge milestone. All right. Now, that being said, we can't see it yet, and the form is still open. So we've got a couple of tasks. Whenever we create a new coin, we want this form to close. Okay. And then we want to be able to see the new coin on the page. All right. So let's go back to our code. What we want to do is take out this console log. Again, we created this toggle create function, or sorry, show create. Yeah, we have this toggle create function that hides and shows the modal. We passed it in here. We've got it here. So finally what we can do is do toggle create and just call that after we create a new coin, and it'll close down the modal and take us back to the home page. All right. So let's go ahead and do that. Let's refresh, connect. Let's create a different coin. You don't want the same one again. So let's just say Doge coin, and then Doge. Click lists. MetaMask will pop up. Click confirm, and then boom, the form closes. And now what we want to see is the newly created coin listed on the page. Now, we haven't actually shown the coins on the page yet. That's because we didn't have any coins to show. So that's exactly what we're going to do in our next section. Okay, so now what we're going to do is list out the token that we just created, actually both tokens, and show them on the page. I'm just going to clear out this, and then boom, there we go. So what we're going to do is go back to our page.js. We can close down list. We're not going to need that anymore. And we're going to need to fetch some new data from the contract. So in order to list them, we're going to basically, let's see here. look at our smart contract. And we're going to read the tokens out of this tokens array. We're going to look at the token sale. We're going to use the token count, total tokens count. Okay. And we're going to load that up into our page.js here. And thankfully, we have this factory contract already loaded up. So it should be pretty easy to get all that information. So let's do it step by step. We've got the factory. We've got the fee. All right. Next thing we want to do is get the total tokens. So we can just say const total tokens equals await factory total tokens. Okay. And then we can build an array, const tokens equals an empty array. And then we can use a for loop to get all the tokens. Okay. And we can basically get the token sale data back, and we can put that into the React state. So a for loop looks like this in JavaScript. We can basically do for let I equals 0, I is less than total tokens, and then I plus plus. So basically what this is going to do is it's going to loop through each token starting with 0. And as long as this iterator here is less than the total tokens, which we just fetched, we'll do this each time, and we can increment it after each point in the loop. So for now, I'll just say console.log, and we'll say token, and then we'll say I. So if I go here, open up the console, connect the wallet, let's just see here. Yeah, token 0, token 1. So it is listed out token 0 and token 1. That's just the iterator 0, 1. So basically for every token in the list, we want to run some specific code. So basically what we want to do is say const token sale equals await factory get token sale, and then put in I. All right, and we'll do console log getting sale. All right, here we go. Boom, there we go. We can see our data. So what we're doing is we're logging out this token sale right here from this mapping. All right, the tokens. We get the token sale come out. We see that the token address, the name, the creator, sold, raised is open. Here you go. Token, address, name, creator, sold, raised is open, true. So that's all the data for each token sale that we're logging, right here to the console. Now what we want to do is actually save this to the React state. So we can say const token, and then we can actually format this into an object like this. Okay. We're going to say const token is token sale.token. We just translate it. Name is the name, creator is the creator, sold is sold, raised is raised, is open, and then finally for images, we're going to get the images and then just pull it into here. Okay. Now let me talk about the images in a second. I'll show you where they're coming from. But what we want to do is actually we want to save this in the React state. So we're going to create a new place for that. All right. So we'll do just below fee. We'll do tokens equals set tokens, use state as an empty array. And then we will, after this for loop, we will add it to the array like this. Tokens push token. And then we'll say set tokens after the loop is finished. Tokens, and then let's do it in reverse order because we want to show the most recent token first. All right. And if we want to, you can do console.log tokens. All right, let's just see here. All right, now we can see the tokens are logged to the console in reverse order. Doge is the first one, that's the last one we created, and Pepe is here. So we don't need to log them to the console, we can keep them here. but we saved them into the React state, and then we can access them in a different component later to list them on the page. But we've loaded them up successfully, from the smart contract. Now, let's talk about the token images. So the images for the tokens are just predefined, okay? If you want somebody to actually create an image when they list their token, there's a little bit more custom programming involved. I can leave that to you as an exercise. But for now, just to get this started, I really want to focus on the blockchain side of things and how to make a blockchain app work, then every single nuanced detail of how this works. Basically, you can see the images are preloaded here from images.json. Okay. So if you look at, let's just see here, images.json, these are actually loading up real Pump.fun tokens pictures with these links. Okay, so we just have 1, 2, 3, 4, 5, 6 different images predefined. All right, so for that reason, we're just going to do a max of 6 total tokens that you could create this application. So let's just see here. We're going to break this loop if it exceeds 6. So we'll add this in. If you want to add more than 6 tokens, you can change this and then add some more images to this array here. All right. But that's where the images are going to come from. So let's just go back. Let's make sure it still works. Yeah, it still works. Okay. So now what we're going to do is try to list these out onto the page. Let's find the place to do that. We're going to create a new listings section. All right. So after this button, after this div, we'll have a new div. Let's give ourselves some space here. Div. And we'll say class name equals listings. Okay. And we'll say one new listings. All right. And we'll list out the tokens. So we'll do it like this. Div class name equals tokens. This is where the tokens will go. Oops, let's kill that. And aside from what we're going to do is we're going to list out the tokens, but we need some conditional logic, kind of like we did here. Instead of adding this later, I'm going to go ahead and do it now. We need to make sure that that the account is present. So basically we'll say that there's no account. All right. Then we want to please connect wallet. Okay. And then if the token's length is equal to 0, then we want to do something else. If there's no tokens, say no tokens listed. All right. But finally, if there are tokens, then we want to do this. What we're going to do is basically map over these tokens. So the map function basically iterates over each element in the array. That's what a map function does in JavaScript. And we can get each token plus its index, and we can show it on the page. Okay. So basically, we're going to say, we're going to render this token component, which I'll show you in a second. It's basically this component right here, token. All right. It's going to take 2 things, toggle trade and then token. So for now, let's just say toggle trade is going to be an empty function for now. We'll add that in a second. And we'll say token equals token. And then key is the index. So each unique if you're rendering multiple things in a mapping like this, React requires that you have a unique key for it. That's what this key property is, and we're just going to use the index from the array. So let's see if that breaks anything. So new listings, it works. You can see please connect wallet, that's working. So we've connected the wallet, and now we don't see anything. That's okay. Let's update our token listing. Let's just see here. It's going to be in the trade. Actually, let's see here. It's going to be in the token.js. Okay. Let's just say, let's give it the token name. Give that name. Connect. All right, so I don't see any new listings yet. That's because I think, let's see, I think we might have made an error here. Yeah, we made an error. So in JavaScript, the type of arrow function that you use matters. So we need to use these here. Okay. If you use curly braces, you have to use an explicit return, but if you don't use curly braces, you don't have to use returns. That's why we're not seeing anything. So there we go. Dogecoin and Memecoin. It's working now. All right. So that's what we want. So we can fill this out inside of here. All right. So basically for tokens, we got the token name already. We can do class name token. We've got the toggle trade function. We're not going to wire that up just yet, but let's fill this out some more. So we'll backspace this. We'll put a div. And we'll say class name is equal to token underscore details, 2 underscores. We'll give the image. Let's just drop this in here. You can see what it is. So the image is going to have a source of the token.image. We'll give it an alt. We'll give it a width 256 and a height of 256. We're going to add these other attributes. I'll just go ahead and drop them in there. Basically created by token.creator, and we'll truncate their address just like we did in the header. And we'll say market cap equals ETH format units, token raised. How much has it raised in ETH terms? All right. So boom, there we go. We've got the new listings. All right. We've got Dogecoin here, obviously with a different picture, and then Memecoin with this picture off of Pump.fun as well. So boom, there we go. All right. So we've listed the tokens on the page. Next thing we're going to do is actually let people purchase the tokens, and that'll be our final task. Okay, so we're on to our final task of this website, which is to let people actually invest in the tokens. So what we're going to do is have a new pop-up, kind of like the create token page, which pulls up the token and then lets them click a button to invest in the token. Okay, so we have to wire up a little bit of user interface stuff. If we go back to what we were working on previously, we have this toggle trade function that's getting called inside of the token.js file. So what we're going to do is create that kind of like we did with our toggle create. So we're going to create a toggle trade function. All right. But before we do that, we wanted to do show trade. And then, so show the create modal is showing create modal, show trade, show create and set show create. We're going to do show trade and then set show trade. All right. And then similarly, we're going to create one like this. That's basically, toggle trade. Okay. But it's also going to be aware of the token. All right. So we're going to pass the token in. And whenever we do that, we're going to do set token. All right. And we also want to have a specific thing for that. So we have tokens. This is for all the tokens. We want to specify which token we've clicked on. So we'll do set token. We'll pass that in here. Set token, because that's what's required inside of our thing. So toggle trade, we'll pass in the token here. we'll save it to the state here. And then whenever the toggle trade function's done, we'll do set token here, and we'll do show trade true or false. Okay. So let's create a way to do that. So down below our show create, what we're going to do is do show trade. All right. And if that exists, then we'll show this trade component right here. All right. Just like we did with the list component right here. So we'll say trade. All right. And we'll say toggle trade equals toggle trade. Token is equal to token. Provider is equal to provider. And then factory is equal to the factory. All right. So if we go to our trade tab, we can see toggle trade, token, provider, factory. That's required. So let's open that, and let's just add an H2 here that says trade. And then let's add some basic details like div class name is going to say token underscore details. And then we'll just give it a paragraph tag with the class name, H2 name, and then we'll just list the token name. Okay, so let's see if that works. So connect wallet. We'll click on a token. All right, I don't see it working yet. Okay, so something's not working. So let's make sure that handler is actually working properly. So, Okay, I see what the problem is. So previously when I rendered each token onto the page, we didn't have the toggle create function yet. So I passed in an empty function. So we just need to do toggle trade right here. All right, let's go back to the page, try it again, refresh, connect, and then click on a token, and then boom, there we go, toggle trade. So now we can see that the trade is there, Dogecoin. Let's go ahead and create a way to close the modal while we're here, just to make our life a lot easier. It's one final piece of cleanup we don't have to do before we get to the really satisfying part, which is actually trading the token. Okay. So inside of trade.js, we're going to create a button at the bottom, right before this closing div. All right. And that button is just going to say cancel. Okay. And we'll say on click. So you toggle trade, and then class name is going to equal button dot fancy. Cancel, and it closes. Okay. Memecoin, Dogecoin's bringing up the correct token name, changes Memecoin, Dogecoin, click cancel. All right. Our basic UI is wired up. So we want to do some more stuff inside of here. We want to add the creator, just like we did with the previous section. Add the creator like this. We're going to add the image like this. We're going to show the current market cap like this. And then we're going to say the basic cost, but we're going to have to wait to get that. So let's see. We'll get the cost in a second. Let's just do this first. All right, there we go. Memecoin, here's the creator, here's the image, here's the market cap. Dogecoin, here's the creator, here's the market cap. All right. So we need to get the cost. So if you go back to our contract you see that the cost, we have to do get cost. So we need to call this function each time that a contract is loaded. So what we're going to do is create a special function inside of trade where we get the cost. So async function get sale details. Okay. And we're going to get things like the target, we're going to get the limit, and also the cost. So we can do this. Const target equals await factory, get the target. We can get the limit, await factory token limit. And we can also get the cost like this. Cost equals await factory get cost token.sold. And then token again comes from right here. All right. So we can save all of these to the React state as well. All right. We'll add some functions for that here with the hooks, target, limit, cost. I'll let you pause that if you want to copy that down. All right. And then we'll save those in our functions. We'll do set target. We'll do set limit. And we'll do set cost. And then finally, we're going to call this function whenever the component loads with use effect like this. Use effect get sale details. Okay. I'll let you pause again and copy all that down if you want to. All right. So what we're going to do is list the cost here on the page. So we can just add the base cost here, and hopefully that will show on the page. All right, refresh. There we go. Base cost 0.001 ETH. That's exactly what we want to see. All right. So now what we want to do is add the final part of the UI. We want to say, we want to see if the limit has been reached or if the target has been reached. And if that is the case, then we don't want them to be able to buy any more tokens. So what we can do is basically say token.sold is greater than or equal to the limit, which we just saved from here. All right. If that's the case, or token.raised is greater than or equal to the target, question mark. Then we want to give them a paragraph, class, name, disclaimer, and say target reached. All right. And if not, we want to actually show the form to buy. So let me explain that. So basically, inside the contract, we're duplicating some of this logic. Factory.sol. Basically, you can see whenever someone's buying tokens, we want to make sure, let's just find it. Did I collapse it? Yeah, I collapsed it. We want to make sure the sale is open, that the target hasn't been reached right here. If sale sold is greater than token limit or sale raised is greater than or equal to the target, we're basically duplicating that logic right here inside the trade UI, right? And say, hey, target's been reached. Otherwise, we're going to let them buy it. So we'll do a form. We'll give it an action here in a second, but we'll say, we're going to give it two inputs like this. Basically, you can copy this out if you want to. Input type number, name, amount. Minimum value is 1. Maximum value is 10,000. And placeholder is 1. That's the max amount of tokens it can buy. This is the min. And then just a button to buy. Okay, save that. Let's refresh. All right, I'll pull this down. There we go. So we can say 5,000. All right, click buy, doesn't do anything yet. Let's wire it up though. to actually talk to the blockchain, and that'll be our final task. So what we're going to do is say action equals buy handler. We'll create this function. That's just like we did with the list handler. We'll create the buy handler here. Okay, pass in the form. And then we will do form get. We'll get the amount from the form, just like we did with the other form. All right. We'll get the cost. Get cost token sold, just like we did here. Okay. We'll get the total cost. Basically, what we're going to do is get the cost times the amount. That's the total amount of tokens they're buying. We'll get the signer, just like we did from ethers.js before. And then we'll do const transaction equals await factory.connect signer buy, call the buy function, and we'll pass in all the required details. Let's look at it real quick. For the buy function, we need the address of the token, the amount, and then we need to send in the ether with message.value. So we'll say token.token is the token they're going to buy. The amount is ethers parse units, amount 18. That converts it to the 18 zeros that we need after the tokens. And then finally, we'll do message.value is going to be the total cost. All right. And finally, we finish. We're going to do await transaction wait. And while we're here, we're going to go ahead and close the modal with toggle trade. That will close it whenever we're finished. So hopefully that is what we need. All right. So what we should see now is when we click the submit button to do our trade, that it will actually pop up MetaMask. We'll buy tokens and we'll see it there. All right, so I think I got a problem here. Syntax error. Let's just see here. Okay, so I forgot to make this an asynchronous function. So async function buy handler. That should fix it. Let's see. All right, click connect. And let's try to invest in a token. Okay. Now let's try to invest some amount. Let's say 100. We'll click buy. And then click confirm. And then let's refresh the page. And then boom, there you can go. The market cap has increased. Awesome. So we have successfully purchased a coin on chain. All right. So that is a huge milestone. All right. We've basically finished our application here. So let's just run through everything again. All right. We're going to connect our wallet. We can list a new token. All right. We can call this, let's say dog with hat with the list. All right. Click confirm. All right, it's listed. And then we can also add a new token. We can call it goat token, goat list, confirm. All right, and then boom, we got all these tokens. Let's say invest another one, 5,000, buy, confirm. And then we can see that that also went up as well. So there we go. We have just finished our Pump.fun clone, our Memecoin Launchpad directly on the blockchain. So congratulations, you've come a really long way throughout this entire project. You have, created smart contracts on the blockchain that actually spit out new tokens. You've created this website that integrates everything. So what are some next steps that you can do from here? You can, of course, address the homework tasks that I mentioned throughout this video. The next steps that you could do would be to take this website and deploy it live to the web so that other people can use it. You can put your project live on a blockchain. I highly recommend just using a test network for this because you don't want to be out there launching tokens without addressing regulatory concerns, of course. And then you can actually make this out there and get other people to use it as a great portfolio project. This is great for trying to break into the industry, learn how to become a blockchain developer. You can show other people what your skills are. And finally, the last thing is, of course, I put a ton of time into creating this tutorial for you all to learn how to become a blockchain developer totally free of charge. And the only thing I ask in return is that you like this video, you subscribe to this channel. Whenever you like the video, it really helps it out in the YouTube algorithm so that more people can see it. More people can learn how to become blockchain developers. And if you want to take the next step to level up your skills, I can show you how to build a pro level blockchain application, put it out there live on the web, and how to increase your income by becoming a blockchain developer over at dappuniversity.com/bootcamp. You really don't have to be an expert to get started today. I've helped people with zero coding experience become real world blockchain developers in a matter of months. So that's all I've got. And until next time, thanks for watching Dapp University.